Here's a masterclass on everything I know about syntropic agroforestry, food forests, and permaculture design. The full download. No fluff, no gatekeeping. Why? Well, because I don't think this knowledge should be locked behind paywalls. And honestly, if you're somebody who's still charging top dollar for this kind of information, the world doesn't need your business model anyways. I want to make it impossible for anybody else to charge thousands of dollars for what should be common knowledge. And transparently, I want you to improve your land with what you learn here, build a positive association with me in your mind, and eventually join the Food Forest Fellowship, where I'll personally help you with your project and give you access to all the in-person events that we run and the online training sessions that we do. So here's how it's laid out. It's broken into 16 different modules covering everything from the fundamentals, design frameworks, installation strategies, species selection, and just all the really practical stuff that'll make this work on your land in any climate. Everything you need all in one place. Enjoy. And hey, if you know somebody who's working on their own project, send this to them. Might make their life a little bit easier. All right, module 1, food forest fundamentals. This is basically ecology. We're learning ecology here, right? We're modeling these food forests and these agroforestry systems off of natural systems. That's the biggest difference between a food forest or syntropic agroforestry and more conventional means of growing. Agroforestry and food forests, it's a process-driven agriculture, process-driven growing paradigm, right? Rather than an inputs-based paradigm from conventional farming, conventional agriculture. So that's why we're learning the foundations and the fundamentals of ecology and how that applies to food forests and agroforestry. A really simple way that I like to explain this is with something I call the food forest equation. Really simple, but there's some details in here to learn and tease apart. Basically, it's time and space over management. So we're going to take this whole module is based on teasing this apart and understanding this, because this is the underpinning of everything: time, space, and management. So time involves the life cycle and species succession, space, layers, strata, and pairs, which all of these we're going to dive into details of, and then management, which is basically your disturbance and accelerator. Let's dive in. So time. First, we're going to look at life cycle. A life cycle is something that every living organism has, whether you're a plant, a human, a bacteria, a fungus. All these living organisms go through their own life cycle, whether it's 5 days, 30 days, 80 days, 80 years. Every species goes through this process and transformation over time, right? Let's use examples of plants, because that's what we're talking about here. So at the beginning of their life cycle, down here, they start off as seeds. And this early stage, they go through this germination process. And as they ramp up, they go through this really vegetative growing stage. Once they get into that second stage, you can probably guess what's happening. There's some indicators. The growth slows down and it switches to something different. They're producing flowers and fruit. So they move from this vegetative growth stage into a reproductive stage, where the growth slows and they focus on creating seeds for the next generation. The third stage is called senescence. That's where the plant starts to die, starts to look a little bit less sad. Maybe it's still got some fruit hanging on, but ultimately it's not looking so healthy anymore. It's certainly not growing. And by the end, you're left with more seeds. That starts the cycle over again. Now, that's an example for an annual plant, for example. The same thing can happen on a 100-year timescale, right? Think avocados versus tomatoes. Every plant's going to go through this. So an avocado, for example, will still have a rapid growth stage in its early years. It'll be in that reproductive stage for a number of probably decades if left and maintained well, where it's just really productive. It's not focused on growing as much. And then it goes into decline, senescence, right? So really simple: growth, reproduction, and senescence. This is the underpinning of a life cycle, right? You're going to keep seeing this pattern explored throughout the rest of this training, but this is a really simple, really easy way to think about this. If we take a closer look, this is called the S curve. If we take a closer look at the front part of that life cycle, right? If we go back up here, we're just going to be looking at this, almost the first half of that life cycle curve. Looking at it here. So beyond that midway point where it's the dashed line, that's kind of looking more into senescence, right? Now, if we divide that first half into thirds, right, there's kind of three different stages of this. And there's a few things we can tease apart here. We're going to keep seeing this as well. But what I want to make really clear is that when a plant is going through, we'll put it in green, when a plant is going through this like exponential growth curve, right, where you check on the plant and like it feels like it's growing a foot every day, right? That's how you know that a plant's in this stage. It's not right after it's germinated, right? It starts off as a seed. It's not quite there yet in that early stage. But then once it hits that momentum, it picks up that speed, it has that kind of like inertia behind it. It's just growing like crazy. And then as it approaches that point on the life cycle, it starts to slow down again. As again, it starts directing more energy towards flowers and fruit. And so the thing to pay attention to here, there's this really interesting idea that kind of shares about at different stages in this portion of the life cycle, a plant is either taking more from the system or it's giving to the system. And when I say the system, I mean like the whole ecosystem, right? No plant in isolation exists, right? It's always connected to an ecosystem, unless you're growing things in a laboratory. In the ecosystem, that's one of the major approaches to syntropic agroforestry in the first place, is you're seeing things from a system level. You're looking at things from a system point of view. You're not taking the individual plant alone and assessing it. So when we're looking at these plants and where they're at in their life cycle as a relationship to the whole system, when a plant is in this stage, it's actually taking more from the system than it's giving, right? It's taking energy from the system to germinate and to get into that stage of growth. Once it's here, in that exponential growth curve, it's giving to the system. It's giving back. It's pumping out great hormones. It's engaged in this growth pulse, and that pulls the system forward. And so in this portion, it's giving more to the system than it's taking. And then the next stage comes, it refocuses, taking energy to reproduce. Put energy into the seeds. That's a really energy intensive process, right? Which is part of also why you want to remove fruit from young grafted trees. Like if you go buy a tree and it's grafted from the nursery, you actually want to remove the fruit in the first couple of years because it's a young plant. The root system isn't established enough. And to create fruit and seeds, that's energetically expensive. And that's energy then that it can't focus on putting and establishing into the root system. So that ties in to this idea that it's then taking more than it's giving from the system when it's in that stage. So we're going to keep diving into the details of this. You'll keep seeing this S curve reappear, but that's a quick understanding of life cycle for a plant, right? It goes through this growth stage, reproduction, and senescence. And at what stage is that most valuable and what is it contributing the most to the system? We're going to keep seeing that pattern explored as we go on. Before we move into species succession, do we have any questions or comments or feedback or input from you guys who are here? Who have we got? Serge, Duncan, Albert, Silver. Yeah, any questions or comments? Serge, you got something?
I got a question about pruning on early years. Some people say that you shouldn't really touch your fruit trees when they're still very young and they're newly planted in a system, but others kind of encourage shaping the tree so that it grows in a specific way. What do you have to say about that?
Yeah, that's great. So the question is like pruning trees that are young and early in a system. I've seen it go both ways. I've seen people delay pruning, but I've also seen really great results from pruning trees heavily that are young because it forces them back into the early stages of a growth pulse, and they have really nice, fresh new shoots to use as that kind of that core foundational and formative pruning. And so that I typically do that with my trees as I do formative pruning. But I think that there's an example from Masanobu Fukuoka from the book One Straw Revolution, where essentially it boils down to the idea that if you start pruning trees when they're young, you have to continue pruning them throughout their life. You can't just like then leave it. Versus if you never prune a tree ever, you have less pruning to do throughout the lifespan of that tree. Now, a lot of the pruning stuff, that pruning philosophy maybe doesn't apply as much to syntropic agroforestry, where we're going to see why, but pruning is such a huge component of this growing paradigm. And so, yeah, I don't know if that fully answers the question, but I've definitely done more pruning on young fruit trees than not.
Yeah, it gives
I
a
have,
correct insight.
sorry. I have a quick question because like once when I bought like some grafted trees like half a year ago, the woman from the shop told me like the first years on the mango trees, like you have to remove the fruit, but when it's fruiting, not when it's flowering. Like there's much difference if you remove the flower or if you wait until it starts fruiting and then you remove the fruit.
That's a great question. I don't think that there would be much of a difference. I've
All
done
right.
both. I've done fruit removal at a young age and flower and fruit removal after. It's like been a few months. I haven't noticed a serious difference. I'd be inclined to just remove it while it's like flowering and young fruit. I don't know why she would suggest otherwise, but to me, it makes sense to just remove flowers and young fruit. So that's what I would go with.
Okay, perfect. Thank you.
Cool. Let's dive into species succession. So species succession is basically that same thing that we just covered. Life cycle stacked with different successional groupings of plants, right? So if you can imagine that, say this plant right here is an annual vegetable, that tomato example, or corn, or squash. You can see the life cycle terminates after a period of time, but then there's a species that comes after that, longer lived, maybe a perennial species. A perennial is a species or a plant that lives for multiple years. Maybe it's 2, 3, 4, 5, 6. And then you see we have an even longer succession species. Maybe think of something that doesn't reach its climax for 20 years. Think of a nut tree or an avocado tree, right? That's the premise of species succession, is that you have these species stacked in time that are going to be productive across different points on that timeline. Right? So you can very simply organize this into 3 different categories. In agroforestry, they're called placenta, secondary, and climax. And so if we bounce back up here, if that first one is our placenta stage, right? Placenta as in like that's the very first stage. It almost contains and gives life to what is to come, right? We all came from that. Every ecosystem to a degree came from some kind of placenta, a succession of species that was there like initially, that gave birth to where the system was eventually going. And so if you imagine a series of species that fits into this category, right? The fast early succession species, you can almost say that like multiple species could fit into that category, right? Into the placenta category. Then we had the secondary. Imagine like a secondary forest, like a young scrubby forest of fast growing species, right? We had multiple year-long species in here. You go into a young forest, maybe one that's 5, 10, 12 years old. That's a secondary forest. All right. And so you can imagine a few different kind of successional groups within that, right? To span whatever period of time this secondary forest exists. And this can be edible species and this can be non-edible species. We're going to dive into that. But at a high level overview, to keep it really simple, we've got a few different stages. And then towards the end, we've got our climax species. Those long-lived nut trees, right? Long-lived timber trees. And so if you want to get a little bit more into the details, there's a few different categories of each of these, right? Placenta 1, placenta 2, and then this second or third category of heavy feeders, right? Imagine these species being the ones that are the first ones to colonize after a disturbance. Big landslide happens. What are the first species to show up? the ones that quickly cover the ground, the ones that take the really intense sunlight. They put their roots in to stabilize things. They shade the ground. They have all these functions. And what happens is, as they grow, they change the environment, right? Suddenly the soil isn't super exposed. It has a little bit more moisture. Suddenly it has a little bit more structure. Suddenly, these species have changed the environment in such a way that now our secondary species have the proper conditions to emerge. Right? Because without the placenta species, maybe the secondary species right here, they didn't have the right conditions. So that's the whole premise, is that these successional stages, it's a sequence of species. It's a sequence of different plant communities that by existing, by growing, they change the conditions and create more favorable conditions for the next group of species to show up. It's almost like if you think of this phrase, I'm going to write this here, because some of these species aren't edible. Some of these are weedy species that you'd be classifying as weeds if you saw them in the local landscape. And so what we're going to do is we're going to call this a repair sequence. Because if we just observed, non-biased, what's happening in the landscapes across these times after disturbance, for example, a landslide comes in, if we can just observe that over the span of 200 years, fast forwarding through the evolution of that landscape, it's a repair sequence. It's sequential in that different categories of species will emerge and then take the place of one another in sequence. And it's all towards the effort of ecosystem repair. That's what's happening. And so that's how you can think about these processes. All of them kind of lead up to a climax community of species, right? These really ancient, old, long-lived trees that eventually disturbance happens. Windstorms happen, lightning happens, and then the succession is reset. That's kind of where these heavy feeding placenta species come in, right? Cabbage, for example, isn't a species that thrives with zero inputs, right? It doesn't want to grow in concrete. So there's a difference between these placenta species that can survive and thrive in accumulation systems, which is what we'll dive into next, right? Accumulation systems are systems with really low natural fertility, right? A heavy feeding placenta species maybe needs a clearing after this climax community has already occurred, right? Because a forest, you think of walking in the forest, it's got this really dark, rich soil with lots of organic material. If a big windstorm comes through and blows that forest down, that's a really rich, naturally fertile system. Maybe the species, the early succession placenta species that are going to be involved in like it there, are the heavy feeders, rather than the really hardy, rugged species that you might see in the cracks of a parking lot. Maybe both of them are placenta species in the fact that they have short life cycles, they come after a disturbance, they don't live for that long, but there's a difference in being heavy feeders versus more accumulator species. And so that's where this kind of comes into play. Understanding what kind of system ecologically you're working with. Right? Are you working in an abundance system or an accumulation system? A lot of this has to do with how much organic material is in the soil, nutrient availability, microbiology, soil life. Obviously, there's exceptions to this rule, but a really easy way to think about it is in an accumulation system, which is primarily where a lot of our landscapes are in, right? A lot of our landscapes need to be recovered more before they can be classified as an abundance system. Like imagining an abundant system is an ecology that can support large mammals. In a desert, it's going to be hard to support large mammals in that kind of ecosystem, in that kind of ecology. In a tropical rainforest where there's big fruit trees everywhere, that's probably an abundance system because it can support the life of large mammals. It can support a large degree of life, right? That's kind of what this is. As this widens, it's the amount of natural capital that there is, natural capital to support life in the system. So an accumulation system really is composed a lot of support species. You might be familiar with that term. If you're not, we're going to dive in a lot on here. But a support species is primarily a non-edible species. That is, its role in a system, ecologically or in an agroforestry system, is to start building towards that abundance ecology, right? Pumping sugars into the ground, putting organic material on top of the soil to build soil, root exudates, nitrogen fixation. A lot of our classic support trees fit into this accumulation system. There are some edible species that do too, but a lot of the accumulation system will be support species. And your role as an agroforester is to move that succession forward into an abundance stage where you have whatever epic fruit you have access to in your landscape. Right? That's the role, is moving from these accumulation systems. You're accumulating organic material in the soil, carbon, nitrogen, biology, life, to support that abundance ecosystem. That's your role. And that's done with species succession, understanding life cycle, and helping to accelerate that. And how that works is you accelerate that with management. This is an epic positive feedback loop. Management is everything. And we're going to have a whole module on management. This is just going to be some like framework level stuff as it relates to food forests and agroforestry and the fundamentals. We have a whole module. We're going to dive into the practical, technical stuff. This is more just a high level overview. Management is this positive, like this positive feedback loop, this upward spiral, right? Where you start off probably in an accumulation system, and you grow biomass. You grow organic material to prune it in situ, on site, on the site. You grow the biomass, you prune it. Your pruning creates a growth pulse. Things grow more, like we saw in the life cycle. Instead of going into senescence, it restarts, goes through this growth pulse, and that results in more life. Then more life results in more biomass. You grow more biomass, you prune more of it in situ, you get a growth pulse, more life. And in that way, it very much is this upward spiral, this positive feedback loop of momentum. It's this beautiful thing to witness. And that's how you move these systems from an accumulation into an abundance state. You grow biomass, you prune it in situ, creates a growth pulse, more life, more biomass, more pruning, more growth. So we look back at the life cycle, just that first initial S curve. There's a really interesting phenomenon here that we want to look at. So right here at this stage, early, before it's really hit that growth curve, let's say it's a little seedling, right? It's just germinated. At this stage, its level of photosynthesis is low, right? It's not performing that much photosynthesis. Once we're here, it's in that growth pulse. It's lush. It's doing tons of photosynthesis. And here, what we're looking at actually is not just the raw amount of photosynthesis that it's doing. We're actually looking at the ratio between its mass and its photosynthesis that it's doing. So right here, it's got a low photosynthesis to mass ratio, right? The mass is high relative to the amount of photosynthesis it's doing. Here, high levels of photosynthesis to mass ratio. And then back up here, once we're focused on it's creating flowers and it's fruiting, photosynthesis to mass ratio goes back down, and especially as we start diving into that senescence phase, right? And so what we're doing is we're trying to maximize for this. We're trying to maximize photosynthesis. That's one of the big principles in agroforestry, is maximizing photosynthesis. And so part of our aim in this whole journey, in this quest of agroforestry, is to maintain our plants in our system in this phase for as long as possible, for as much of time as we can, maintain our system in this exponential growth curve where photosynthesis to mass ratio is high and things are pumping. Now, obviously, there's going to be exceptions and times where you need to get a crop. That makes total sense. But as much as you can, try and keep your system in this growth phase, maximizing photosynthesis. How do you do that? With your disturbance. And so that's why the disturbance was placed right here. Before it starts to even decrease that photosynthesis to mass ratio, before it gets into that reproduction stage. If you don't need it to, for example, if it's just a biomass species that you don't need to go to flower, you don't need it to set fruit, set seeds, once it goes through that and it starts slowing down, you become that disturbance. You prune it, you hammer it, and it produces a growth pulse. And that's how you accelerate succession, right? Because what happens is all these plants are linked hormonally, right? They're all communicating underground. Again, it's not just an individual plant in isolation. Everything is connected. That's systems level thinking in agroforestry. It's not about an individual species. You can't just tease one thing out. It's a system. It's all connected. And so when one plant nosedives into senescence, it drags everything else with it. It communicates, hey, it's time to go into senescence, especially if you've got a whole forest, a whole system doing that at once. It's going to slow everything down. So that's why the timing of these disturbances, the timing of these prunings, super important. So right before that goes into senescence, we're heavy pruning it, and it's creating that growth pulse. Same thing on the next succession and the next one. And so what's happening here is you're also creating opportunities for yourself to add new plants in. And this is when you're doing that. Because nature, in these wild natural ecosystems, never stops incorporating new plants, nor should you, for two reasons. One, you're never going to get it right on the first time. You're going to keep wanting to add plants. You're going to want to keep adding new species in. And depending on how you want to plant them, how you want to incorporate them depends on how you want to do it, right? So if you're adding new plants, if you're adding seedlings, already germinated things, grafted trees, if you're adding things that are already alive and are already a small little plant, you want to add them in during these disturbances. You don't want to add them in to an already growing system in the middle of a growth cycle, right? You want to add your new plants in while or after you've done a heavy disturbance. That's for plants. If you're talking about seeds, you can add seeds in anytime, and you should be, just like the birds are, right? Continuously adding seeds into your system. So your system's never done just because you planted it a year ago. Keep adding seeds in. And one thing is especially true is because when you plant your system, when you start it off, you're only going to have access to so many seeds because some things just aren't ripe. Some things just aren't available at that time of year to plant by seed. That's okay. Set your system up at the start of the growing season. And then as it continues for the next 12 months, keep adding seeds in as they become available. So seeds you are adding in perpetuity at whatever stage you want. They will germinate on a cycle. They'll get incorporated. When you're adding new plants that are already alive, seedlings, grafted trees, rooted cuttings, add those in on your disturbance intervals. So here's what's happening. You have an overgrown system, right? A healthy system. It starts to slow down. You do a heavy prune. You drop a bunch of organic material, that positive spiral upwards. All that organic material, stranded nutrients. You've disconnected them from the living system. Now they're on the ground. What happens is nature doesn't produce waste. There's no such thing as waste in nature. Almost immediately, as soon as you drop all that organic material on the ground, you get it nice and in contact with the soil, you organize it well. We'll get to all of that. That material, those stranded nutrients that are in those branches, in those leaves, in those logs, they get reabsorbed and reincorporated into the system. So on top of having an actual growth hormone response, right, gibberellin or gibberellic acid is the actual hormone response that these plants go through. They all communicate and say, cool, it's time to grow. We've just been pruned. On top of that, they're also getting this huge dump of organic material, new nutrients, minerals to accelerate that growth. So they're getting new sunlight because you've just done a heavy disturbance. So a lot of these plants in the understory, that new sunlight, especially for these low strata plants, which we'll get to, low strata plants really rely on those heavy disturbances to induce flowering, to ripen their fruit. And so you're doing so many things with that one primary action of pruning. You're getting a growth pulse, you're getting more sunlight, you're getting more organic material on the floor, you're accelerating the population of the microbiological activity in the soil, right? More worms, more fungal activity, more bacterial activity. If you're pruning your nitrogen fixing trees, they're dumping a lot of that nitrogen in on those moments. There are bacteria colonies in the base of this on the root systems, right? So let's say that this tree right here is a nitrogen fixing tree. That doesn't mean the tree itself is actually fixing nitrogen. It's connected in a symbiotic relationship with all these different bacteria nodules on the roots. And when you prune that tree, when you prune some branches off, it's going to shed a portion of those nitrogen fixing nodules, those bacteria colonies, and suddenly that flush of nitrogen is also available to the trees around it. So again, with that one primary action of pruning, you're doing so many things: more sunlight, more organic material, better moisture retention in the soil, hormonal growth pulse, nitrogen fixation. So many things are happening just from that primary action. And that's why management is 95% of the work. We'll dive into more of that, but management's everything of a system. It can make or break it. So in essence, those are the food forest fundamentals: time, space, management, right? Life cycle, species succession, growth pulses, accumulator systems and abundance systems, the positive spiral, the positive feedback loop, management, the role that it plays, timing that, photosynthesis to mass ratios, regular disturbance intervals, when to plant new things in the system, and all the result of that one primary action.
Sorry, my connection. Yeah, like it doesn't matter if you prune like constantly, like every week, if you need it.
I wouldn't be pruning every week. I think that the nature of these systems is like doing a heavy reset and then allowing it to fully recover. And so it's not small
All right.
pruning, it's not little pruning here and there. It's large, heavy prunes at regular intervals, and you're repruning it once you've allowed it to recover. And so we'll dive into the details of that on the actual management module that's towards the end of this.
Can I ask a question as well?
Yeah, let's go, Tom. How are we doing?
All right, got it.
Yeah, good. Um, so I've just installed the system 3 months ago, and I haven't actually seen any growth on the system. So it's a temperate system, and I've just kept adding herbaceous layers. So pretty much every 2 weeks, I just find new things to add into the herbaceous layer. So things like catnip, and I keep sprinkling seeds on, and just found some more yacon crowns, like with people harvesting in the area. You were saying like adding seedlings in that growth period. Like I haven't really had any growth in the last 3 months. Do you reckon that's okay, or is it better just to stick with adding plants at one point after a pruning cycle?
Yeah, that's a great question, because you are kind of you're creeping towards the middle of winter and creeping towards basically the dormant season for temperate systems. And so if that looks like adding a bunch of species that are more or less dormant throughout the winter season, I would be super comfortable doing that. I'd be just like continuing to add these dormant species. And then once spring kicks off, once it kind of like does enter that growth curve, then I would kind of like hold off on incorporating new things until you do some kind of intervention. So taking the winter while everything is dormant, stacking the system with whatever you can find. And once it picks up on that growth curve, then kind of like step back and let it do its thing. And then when you're ready, come in and intervene.
Yep, cheers.
And hey, if you're enjoying this, tag a friend or share it with somebody who just got land and they're just not quite sure where to start. The next chapter for the food forest agroforestry fundamentals is space. Understanding how these systems, how these food forests, how these agroforestry sites evolve in space, not just time. We spent a bunch of energy looking at time management, and space is that third component of the food forest equation. And you can really easily divide it into kind of three different subcategories. We've got layers, strata, and pairs. We're going to start with layers because you might be most familiar with that, especially if you come from more of a permaculture or a food forest background. You can Google what are the food forest layers, and you'll see all these beautiful diagrams online. So we're not going to spend tons of time diving into this, especially because I don't find it to be the most helpful framework in agroforestry, but we are going to cover it because it does have some particular uses that I want to explore. So the layers of a food forest are many, depending on how detailed you want to look at it, how old the forest is, right? You can have a really complex 17-layer food forest or agroforestry system, or just a natural forest in general, if you look really detailed and tease apart all the layers. In general, things become more complex as they age, right? So we're going to look at a really simple, basic outline of the different layers of a food forest, right? This is kind of what you'll find if you look online. This drawing is quite truncated. Layer one right here, we'll start with the biggest. We've got big trees. We're going to keep the language really, really simple, easy to understand. Just the biggest trees you can imagine. Lots of nut trees fall into this category. Then we've got, really simple, medium trees, right? A lot of larger fruit trees fit into this category. Not going to give specific details, but just at a pattern level. Then we've got small trees. These are a lot of our dwarf trees, things that we see that fit really nicely right around the house. After the tree format, we've got shrubs. These are woody things that usually have multiple stems. Shrubland. After that, we have the herbaceous layer, the non-woody. That's the difference between shrubs and herbaceous. Herbaceous is anything not woody. So even, I'll give an example here, bananas fit into the herbaceous category, right? Think blueberries for shrubs, or raspberries or hazelnuts, right? These are all temperate examples aside from the banana. After that, we've got ground cover, which is kind of herbaceous, depending, but it's another layer, especially if you look at a lot of the food forest literature online. After that, we've got tubers and fungi, underground components, and our mycelial friends, our fungi. Then we've got vines, aquatic plants, and this last one right up here, epiphytes, things that grow up in the trees without that root connection down to the ground. All right, so if we put this out on the list, we've got big trees, medium trees, small trees, shrubs, herbaceous, ground cover, tubers and roots, fungi, vines, aquatic, and epiphytes. Now, again, like I said, nature doesn't fit nicely into boxes. I'm sure there's something missing in here. Guaranteed. However, what I find this to be really useful for is a mental framework or a checklist. As you're designing or installing or planning a food forest or an agroforestry system, if you run through this checklist and make sure you've got at least one or two of each of these, you're guaranteed to have a really diverse food forest. There's no way you won't have a diverse food forest if you go by this checklist. To me, that's where the value of this framework stops. I don't use this for anything other than a checklist because in a lot of ways, it's almost too complex. It creates too many different categories. Most of what this is about the physiology, the physical growth habit, the physical form of a plant. And in many ways, that's not as useful. It's helpful as a checklist, as a framework to make sure we've got a huge diversity of different kinds of plants, but there's a different kind of way of organizing our understanding of space, especially in agroforestry. So this is useful. This is kind of like a rudimentary, rough, easy way of getting into the next category of organizing information, and that's strata. So hopefully you've got some lists running around in your head now with the different layers of food forest and the different species that can apply at your site and your context and climate. But now we're going to look at strata. If you're ready for personal help with your project, consider joining the paid fellowship. I work closely with every single member in there on design and implementation, no matter where they're at. The link is below. But now we're going to look at strata, which a big misconception here is that strata is about height, right? In many ways, that's kind of closer to what the food forest layers looks at. Strata is about light, not height. It's an easy way of remembering. Light, not height. Easy example of this is corn. Corn is an emergent strata layer right at the top, right? But so are other trees. Other trees that can be 20 meters tall compared to 2-meter corn. Both of those can be emergent strata because it's about light, not height. So keep that in mind as we're exploring what does strata mean, especially in the agroforestry context. This is what you're going to see used more frequently. So we've got 4 different strata to keep things really simple. Again, not everything fits in neat little boxes, but we're going to keep this simple for now. We've got E, our emergent strata. These are things that want full sunlight, full sun. And here's the thing, most trees don't. Most trees, most fruit trees especially, are not actually emergent strata, full sun. Most of them are high or medium strata trees. They want a little bit of shade, or they want a degree of shade above them. All right, so an emergent species in your food forest system might only want to occupy 20% of the canopy of that layer, right? Here's an easy way to think about that. If we're just looking, I'll draw this in red. If we're just looking across the emergent layer, maybe only 20% of that canopy wants to be occupied. That's what the 20% means. And so then if we're looking at the high layer, right, that's our next strata. These are larger trees, right? Just below the emergent. If you're looking out at a hillside of forest, most of what you're seeing visually is the high canopy. The emergent ones are the trees that just stick their head up and wave around at the top. Most of the canopy from the outside that you're seeing is the high canopy, a high strata, right? And so if you're looking across this high strata layer, that wants to be maybe 40% of that layer, right? Of that canopy strata occupied. All right, so not 40% of the whole thing, but if you're just looking across the high strata layer, 40% occupation. And this is going to make sense, especially when it comes to management. But for now, just bear with us. Next, we've got our medium. These are trees that want even more shade, right? Because it's about light, not height. And so our high canopy trees want some degree of filtered light above them, right? Our medium trees want even more heavily filtered light. Right? And maybe these medium trees are going to occupy 60% of that layer, right? Again, keeping it just understanding about looking across that one layer, across the medium strata, 60% of that layer wants to be occupied within the medium. And then low, 80%. Most of that wants to be covered. You want to catch any residual sunlight because at that stage, the sunlight that's available has already passed and filtered through a lot of the system. You want to catch any little, that's where the scraps of sunlight are coming through, right? Because you've just passed through a 20% emergent canopy layer, 40% of the high, 60% of medium. You just want to catch as much of that sunlight as you can that's left at the bottom of the system with your low strata. Now, this is dynamic, right? In many ways. One way in which it's dynamic is the actual strata itself of a plant. Let's say, for example, the avocado that wants to end up becoming a high canopy species. That doesn't mean that it starts its life out as a high canopy species. It starts its life out in the little understory, kind of almost occupying more of a low space. Throughout its life cycle, a plant will change. A plant will develop. So in many ways, what you're looking for is what layer is a plant, or what strata does a plant want to be at its maturity, right? When it's in the reproductive top of the growth curve of its life cycle. Another thing that can influence what strata a plant is it getting everything it needs? For example, lettuce, if it's given all the nutrients, all the fertility, all the minerals, all the water that it needs, if you're giving a plant everything it needs, that lettuce can probably be an emergent species and do really, really well. If it's deficient in some of those, maybe if it doesn't get enough water, it doesn't have enough nutrients or minerals, maybe it needs to be a lower strata to be able to be healthy. It can't tolerate the full sun. So a lot of this depends on where it's at in its life cycle, and does it have everything it needs to be as healthy as possible. So that's a quick overview of strata and how it can be dynamic, broad pattern level. Also understanding that these strata are dynamic and it becomes more complex over time. All right, so the canopy complexity will actually increase as time goes on, which means that no longer is it just emergent, high, medium, and low. Then you start to get things like medium high and medium low, and becomes, like I said before, this more gray area. Nature doesn't fit into boxes. And so if somebody asks, what exact strata is this? The answer might just be, well, it depends. It depends on what climate you're in, right? If you're in a really tropical climate versus a subtropical climate, intensity of sunlight might have an effect on what strata a species is. How complex is the canopy? How old is it? All these different things come into factor. So canopy increases in complexity over time, right? It starts out, it might be really simple. Things complexify. It's a natural system. Are there any questions about that from anybody who's in here live? Strata overview. We're going to touch on this in management in terms of the percentages, because obviously plants don't stay nicely and neatly at these percentages. And so we're going to discuss how do you manage to keep them there. On to the next one. And hey, if you're getting value from this, share this with another permaculture designer or a food forest consultant that you know might improve their practice. So we've got strata pairs. This is just off the back of our conversation of understanding the strata themselves. When you're doing things commercially, when you're doing things at a larger scale, you need a little bit more simplicity. You need things to be more efficient for management. You also maybe just need more production than if you're just a home gardener or a backyard. Strata pairs become really important. Here's what that looks like. What you're doing is you're pairing up distinct strata, right? So instead of having all your strata packed into the same place where they might start to crowd each other out or just require way more management and be able to be less productive, what you'll see often is the pairing of these two different strata, emergent and medium, high and low. You're basically skipping a strata layer, right? So instead of also incorporating the high in here and the low, you're giving them their space so that you can have that emergent, you can have plenty of space, plenty of sunlight, and then you have your medium strata. All right, so maybe an example here is some kind of nut tree and a citrus tree, so that everybody's getting the airflow, the sunlight requirements, the ease of management. Or maybe you're doing avocados and coffee for your high-low pairing. Choose whatever species are relevant for you, especially if you've got this scale or if you're going into that direction. Think carefully about how you want to pair your strata up so that you're not constantly having to tease the layers apart. Because if you have these in the same place, there's a lot more management required, a lot more effort to maintain that, and things will generally be less productive. And so we'll dive into the layout stuff, and this is where this is going to resurface, but you can actually tease these apart into separate lines. And so what you see often, these kind of examples or these levels, is A, B lines where you're alternating. Emergent medium, high, low, emergent medium, high, low. So that's a really quick intro into strata pairing. Again, all these patterns will continue to resurface as we continue moving through this lesson. But that's been an overview of the food forest and agroforestry fundamentals, the whole equation: space, time, management frameworks. Hopefully you learned something. I'll see you guys in the next module. All right, we've got design process module up next, exploring context and what that even means, right? One of the things that is really important is that this is not a step-by-step formula, right? And what you see online, or whether you read books, what you typically see in a design process is that it's spelled out step by step, when it is not that. Now, what you normally see, you read these books, and step one is design, or observe, design, install, and manage. It seems pretty straightforward. It seems like, yeah, that's a natural progression of things. And it is, but I want to be very clear about something, and I want to draw attention to this, is that it's a sequence, but it's also simultaneous, which is why it's not a step-by-step thing. I want to explain visually. On this graph, if you've got on the y-axis, on the upside, intensity of the activity, on the bottom you have time, you take those 4 steps where number 1 was observe, the intensity of your observations is really high at start. And then it slowly maybe moves down. But that second activity, right, observe, design, your design doesn't start immediately, but it intensifies, and that becomes the main activity, and then it fades down. Installation being your third activity, your third stage, same sort of deal. And then management, right? Now there's a long tail on management, because management is 95% of what the work, right? And so as you go, you're doing all these activities simultaneously. Like, look right here. Right before you're about to do the installation, you're still observing, you're still designing, and you're installing. You're doing all of this at once. And to a degree, you're still managing. And so that's the thing that I don't like about a lot of these books that you read, is they make it seem like once you've done observations, you move into design. And then you move into the install and the management. And it's this step-by-step thing where you can only do one activity at a time. And that's absolutely not how it is, though. This is a living process. You're doing all this stuff simultaneously. You're making observations. You're still doing design even after you've installed it. You're doing all this work simultaneously. It is a sequence, and there's different levels of intensity to it, which is why I think this is important. What we're going to cover here, we're going to cover the observations. What kind of observations should you be making with your land to understand your own context and how that pairs with the landscape that you're in? Give some detail, because it's easy to say, yeah, go make the observations. What are you paying attention to? So this is going to bring some clarity to that. There are 2 main things that you're looking at here with observation, and it's all to develop context. Context is the combination of these 2 spheres, right? Right here in the middle, where the people and the place overlap. Right, so on the people side, this is everything about you. All your hopes, wishes, dreams, everything you want out of life, right there on that side of this Venn diagram. On the other hand, the place is all the possible potential things the place could do and be, right? Like your land, depending on where you live, could be turned into a shopping mall. That's in the potential, maybe, for your land. Or it could be a space observatory, right? It could be a million things. The key, where it's important, is where those things overlap. Where you, your family, all your hopes, dreams, and wishes overlap with what's possible in that landscape? What's the potential in that land? That's where it's important, that middle area right there, where you both combine. And that's why context is everything. Like, sure, the land has potential to be all these things that you probably don't care about. And there's all these things about your life that probably aren't really relevant to the land itself. And so context is key in understanding this. And that's why there's a joke among permaculture designers that says, you know, when you ask a question of a permaculture designer, the answer is, it depends, or it depends on the context, because it always does. There's no one right answer. Usually that's why it's hard to give really specific, detailed advice. If you're unfamiliar with the context, you can't give a good answer. And that's why the emphasis here for this first stage is understanding your context and getting really clear on that. As a permaculture designer, that's part of the work that I do and that you would be doing, is just really getting a lot of clarity and articulating what is your context. Because if you're able to articulate what it is you're trying to achieve, it becomes much, much easier. The decision-making process becomes very simple and straightforward because you know what to say no to, because you know what direction you're moving in. And so what we're going to look at is, what are the actual things within those two Venn diagrams that you're observing? You're observing yourself and the landscape. So we're going to start with yourself, the people side of it. What are the things to pay attention to? I like to imagine them as not just Venn diagrams on one plane, but three-dimensional things that you're kind of moving downwards through. So you want to be paying attention to your goals. What do you care about? Why are you doing this in the first place? You should be able to go 7 layers deep answering why, right? If you tell me, I want to start a cherry orchard or a cherry food forest, say why? Oh, well, because, you know, my grandfather used to make these awesome cherries from his thing. And why? Why is that important for you? You should be able to answer 7 layers why, right? Have a deep understanding, because then that just brings so much more power and clarity to where you're going. What's the vision that you have? Do you want to just self-isolate and be up in the mountains with your epic food forest? Do you want to be a hub for your community? Do you want to be a nursery? Understanding your vision and having a clear idea of that is a huge component of that self-analyzing to develop your context. And that's something that's always changing. The vision can, you know, adjust here and there, but just having that level of clarity and being in touch with that goes a long way. Really, really makes this whole process a lot more simple and easy when you understand why you're doing something, the goals you have, the vision. The next thing is a little bit more practical. What are the skills that you have to bring to this? Are you an arborist? Are you a builder? Do you have seed propagating and germination skills? Did you work as a market gardener? What skills do you have to bring to this? Maybe you're really skilled with animal management. These are all things that you can begin seeing how they fit together in this puzzle. What resources do you have? Do you have tons of money to throw at this thing? Or do you have tons of time to throw at this thing? Or do you have both? Do you have community? Can you lean on community and neighbors? Or do you have great family that you can lean on? Or are you connected with a local arborist who can be a source of mulch for you? What resources do you have in your field to lean on to bring this vision to life? Now, one of the things at the bottom of both of these columns that's almost more important than the top part of the column, we're going to do a different color for down here. Because in many ways, that's all great. Like this, you know, your vision, your goals, that's fantastic. Everything has potential. A landscape has infinite amounts of potential, just like you do as a human being. But what's more important than the potential of a place or a person are the limiting factors. What are the constraints? Because ultimately, everything has this unlimited potential, for sure, if given the right circumstances. But the reality of the situation is we have limiting factors. The landscape has limiting factors that are going to constrain what the opportunities actually are, right? I can have a goal or a vision to make an agroforestry system on Mars. Great, there's potential for that. But the limiting factors mean that realistically, that's not going to happen. And so paying attention, really close attention to what your limiting factors are, is almost more important than how big can I dream? What's the massive potential? I almost stray away from using that word. It's the dangerous P word in permaculture design or agroforestry, is potential. Like, yeah, we get it. Your land has potential. Every piece of land has potential. What's more important and more interesting are the limiting factors. So figure that out. Take an honest assessment of yourself, of your life, of your situation. Be really honest with yourself about your limiting factors and see if there's something you can do to change them, right? Maybe it's just a reallocation of time, energy, having some conversations that need to be had to resolve some of those limiting factors. How many of those can you erase so that you have more opportunity and more capacity to dive into that potential? So I'd say focus here, focus on the limiting factors, play within that realm, see if you can expand it. So that's the people side of things. I think that's really interesting. Exploring that, there's so much potential to see, and I use the dangerous P word, but really lean into figure out what is your capacity, what are your goals, where are you aiming, and what are those limiting factors for you? For the other side of things, on the place component, we're actually going to look at the scale of permanence, which, working our way down, is a framework really helpful to prioritize what to pay attention to in the landscape, right? It's all good to say, go to the land and make some observations. What am I supposed to be observing? What am I looking at? And hey, if you want to go deeper, join our free online community, the Food Forest family. It's packed with additional resources, templates, PDFs, projects, and just connect with the other practitioners around the world. Scale of permanence. So this is a framework for organizing our observations in the landscape, prioritizing, right? What are we paying attention to in what order? How do we weigh certain observations, right? This was developed by P.A. Yeomans, and it's just a way of really prioritizing what am I supposed to be paying attention to in the landscape when it comes to thoughtfully designing a permanent system, whether it's agroforestry, whether it's farm, whether it's a house site, prioritizing your observations. And really what this is we're working downwards from the most permanent things in the landscape to the least permanent. So almost, it's not that they're unchangeable or permanent, but these first things up here, like that's why number one is climate, takes the most energy to change, right? It's not unchangeable, but as we work our way down, things become easier and easier to change. And so number one is climate. What are we actually paying attention to and observing? What we want to be looking at, you want to go online and figure this out. If you're not familiar with your site already and the climate, if some of you are new to this whole thing, you can Google this, you can use ChatGPT, figure out what the records are. Record highs, record lows, whether it's temperature, right? How cold could it possibly ever get here? How cold has it ever gotten here at this site? How hot has it ever gotten? Look at the records. Also look at records for rainfall and wind, right? How windy can it possibly get here? How wet can it possibly get here in a period of 24 hours? How dry can it get? What's the longest it's been without rain? Right? So really looking into these extremes, that's what you want to be paying attention to. Yeah, it's helpful to know the averages and kind of how things more or less exist here, but look at those extremes: flood, wind, rain, fire, right? Storms. Pay attention to these things. That's what you're looking for. Another really interesting thing to be looking at for climate, especially as it relates to understanding how you can model your own agroforestry and compare it to other people's agroforestry around the world, is understanding your climate type, right? This is really easy to find by Googling climograph. A climograph is a combination of three things: average temperature, average precipitation across time for your site. And so if we look down here, we've got a year, right? Maybe broken up across the months. We've got a year on the bottom. A climograph, if you Google your city or your town or your region plus climograph, you'll probably see something like this, where it's got a representation of how the temperature is changing throughout the year on average, allowing for some wiggle room, and then how precipitation or rainfall changes alongside that, right? And so here we can see that temperature is relatively high. It raises in the middle of the year and then it drops back down. It's not super extreme. It's not really consistent all year long. And kind of the same thing with rainfall, right? It's not super low. It's not crazy high all year. It's got a moderate change throughout the year. This is what typically subtropical climates look like. It's quite moderate, pretty warm, pretty good rainfall. So we're going to look at the 4 kind of main patterns that we're seeing in climate. Here they are. We'll start with tropical, where we've got really consistently warm temperatures throughout the year. We can also see relatively consistent rainfall if we live in a wet tropical area, or if you live in the dry tropical area, you can see rainfall can dip down. When you move over to subtropical, it's quite similar, but just less tropical, right? Maybe a little bit less warm and a little bit more seasonality. And that opportunity is still there for rainfall to be consistent, to be seasonal in either direction. But it's just a more moderated kind of tropical climate. A little bit more seasonality. We see an even more extreme of that when we go to temperate, right? The temperatures drop lower, still it's very much more seasonal, and similar with the rainfall, right? Can be moderated throughout the year, can be a little bit more on the extreme ends. And then we move into Mediterranean, where it's almost inverted. We get really high temperatures, but also the opportunity for lower temperatures seasonally. And rainfall is inverted to the temperature. So usually you end up with these really hot and dry periods at the same time and lower overall rainfall, right? You can see where rainfall is sitting down here versus up here in the tropics, right? These are patterns. This is, again, nature doesn't fit into boxes. You can't very easily classify all of these different climate types into 4 different averages, but this is a general assessment of like how to read a climograph and some 4 easy examples that your site probably fits into one of these 4. And so then that's helpful for thinking of, all right, well, if climate is our first consideration in the scale of permanence, I'm looking at records, extremes, I'm understanding the climograph, and that's going to dictate a lot of our growing season. It's going to dictate what kind of plants we can grow, etc. The second thing we're looking at is the land shape, right? Here you're looking at topography, and this is a really great thing I want to highlight, is you want to be accommodating your farming or your growing practices to the landscape, not the inverse. What does that mean? Look at the landscape and see what kind of agriculture suits this landscape. Do that. Don't try and force the landscape into your kind of agriculture. Right? That's going to make more sense as we dive into this next piece. So you're looking and reading the topography, you're looking at reading slope, you're looking at aspect, where you are in the watershed. Maybe your site's up on the mountaintop. What should we be prioritizing there versus if we're in the valleys or the foothills, right? Up on the mountaintops, erosion control. That's one of the best things we can do up on top of the mountains, is get them into permanent tree cover. It's easier to slow the effects of erosion if you start at the top, right? Reduce erosion by creating permanent forests, PFs, on those mountaintops, on the ridges, higher up, right? Permanent forest, trees, reduce erosion. In the foothills, this is probably where some kind of agroforestry wants to be happening. Some kind of tree-based growing paradigm, possibly with grazing in a controlled way, right? Not just free roaming grazing, but some kind of controlled grazing plus agroforestry in the foothills. Again, tree-based agriculture. In the valleys, this is where some kind of, again, crop production and agriculture, agroforestry wants to happen. Maintaining biodiversity. These are places that are natural accumulation systems, right? Natural accumulators of water, minerals, nutrients, organic material. So making use of that to grow food and do it in a regenerative way. Agroforestry systems, high biodiversity. And then we have streams and floodplains. Again, this is just reading the landscape, seeing where do you live, And what might some of the best land uses be based on that? Because again, we're accommodating our farming practices to the landscape, not the inverse, right? And so streams and floodplains, we want to have some kind of riparian buffer, right? We want to have trees that surround the waterways. We want to keep animals out of the waterways. We want to do wetland restoration, right? Manage flood risk. I know that's happened a lot in New Zealand and probably globally, is the wetlands have been drained across the whole country. And so it's no wonder that our cities and our towns experience these crazy flooding events, because wetlands were the sponge, right? Now, with a lot of our hills being deforested, the mountaintops and the foothills not having trees on them either, water violently shoots down. Suddenly it has no wetland to act as a sponge. It's channelized, and so it just blows right through, has all these negative impacts, right? Ecologically, we've removed the sponge and we've accelerated how erosive and how much degradation can happen by removing the trees from higher up in the landscape and then removing the sponge to catch the water. And so on both ends, we've kind of screwed ourselves, which is why this stuff is important, like how to manage a landscape. Trees. Trees are the answer. Plant trees. So that's a classification if you're looking at different parts of the landscape and how to kind of accommodate your farming practices to where you're at. What's the topography? So that's thing 2 to pay attention to. The third part of the scale of permanence, water, kind of ties into the landscape management. All this ties together. It's all a bunch of patterns. The 3 main core elements of what you're looking to do, you're trying to slow it, spread, and sink the water into the landscape. So that example before I gave of like violently rushing down the slope, as soon as you start planting trees, what happens is suddenly they send their roots down, they accumulate organic material. The rain that does fall isn't as erosive or as big of droplets. The canopy breaks it up into smaller, less violent droplets. The roots provide tunnels for that water to drip down, infiltrate into the soil better. The organic material slowed everything down. And suddenly you're rehydrating the landscape, you're slowing it down, you're spreading the water out, and it's sinking in. Planting trees has a magical impact on this ability for a landscape to retain water, retain moisture, reduce erosion, which is why our hilltops should be covered in forest. Anytime I see a hilltop and it's not covered in a forest, it feels naked, it feels nude. I want to cover it up. You can also do this with earthworks. And you can go back and forth between, should I do earthworks or should I just plant the trees and let the trees do the work? Classic permaculture answer, it depends. But if you're doing earthworks, a really simple approach, not a simple approach, but a really common approach is with the use of swales, which is where you create a ditch, and then the downhill side of that, you place the soil, the material, and this runs on contour, level across the slope. And so what it does is it catches this water, it fills this, and it spreads the water out along towards the ridges rather than shooting down the valleys. And then you do is you plant trees here. So the water sits and it rehydrates. It soaks in, it feeds the landscape, feeds those trees. Another example, instead of the water just shooting violently straight down the valley, right? When there's no trees, no vegetation to hold it together, it's just, you've seen examples of this, just gullies just eroding. The water moves very quickly, a lot of power. Water is very, very powerful. Imagine standing in front of a fire hose. You want to move. It's erosive when it's moving so fast. So that's why our role is to slow the water down, allow it to rehydrate the landscape, spread it out. Instead of just shooting down the valley, move it out to the ridges, which are typically more dry. You can do that with all sorts of things. You can do it manually with a spade. You can actually dig these kind of swales If it's not so steep, you can do it with machinery. And so it's a big gray area. How do you decide what to do? Do you just plant trees? Do you do earthworks? One of the common patterns that I've heard and understood is that if the land is steeper than a certain degree, you're better off not doing earthworks and just planting trees. Because those trees are going to perform the function anyways. They're going to slow the water down. They're going to add a level of resilience. That number was 15 degrees. So if your site is steeper than 15 degrees, which you can figure out how to calculate that, it's not recommended to do earthworks. Just plant it in trees. Whether that's an agroforestry system or it's just a reforestation effort, we'll look at different ways to like tactically do that. But that's the general guidance. If it's more steep than 15 degrees, don't do earthworks, just plant your trees. And this is all in service of managing water. You're also planting water when you plant the trees. They're doing so many different things. They're having water stored in their root systems. They're transpiring more. They're reconnecting the water cycle. That's part of the problem, is that we've broken the water cycle. We've deforested the hilltops. We've removed the sponges, right? We've removed the wetlands. We've broken these water cycles. And so it's no wonder we're having all these issues. By planting a forest, you're rebuilding, you're helping to recreate that water cycle. They transpire, they put more moisture in the sky, they keep more moisture underground, they reduce erosion. There's all these different services that come from planting trees. So go plant some trees. Where do I do my earthworks then? Where do I store my water if it's not right at the top or it's not on the really steep part of the hill? On the key point. The key point, and there's millions of key points. It's a fractal thing. You can see big key points, small, minor key points. The key here, key point here, is that transition point, right? Where it goes from a convex curve to a concave curve, where it switches right there. It goes from steep into more shallow. That's the biggest, like that's the money spot right there for capturing water in a landscape. So look in the landscape, you can look at like a topographic map. You can see the same thing where the lines go from being really close together to more spread out, where it changes in slope from steep to more shallow. That's your key point. If you're going to do some work there, whether it's a pond, whether it's starting a swale system, that's the money spot. Number 4, in terms of the scale of permanence, access. This is more mainframe design. This is like 30,000 foot view of your farm, your property, your site. You're looking at, where do I put the roads? How do I design access, right? The key here thing is you're designing for future needs, because not every time, and most often we don't understand what we're going to need. So giving yourself options, what might we need in the future? Where is this project potentially going? Cool, let's think about what the needs might be in 5 years, in 10 years, in 15, 20 years. What might this project need? And so I classify it in 2 different ways. You've got major access, or like, are you going to have to be bringing big trucks in, whether it's for construction, whether it's for big harvesting operations, machinery, equipment. Maybe there's just internal truck roads for smaller vehicles, tractors, right? You're thinking about how do you access and how do you make all these different parts of the land accessible? Maybe there's minor accesses that you need to be focusing on, or that's more relevant for you. What areas are you going to be managing with a brush cutter? How do you need to be able to move around with a wheelbarrow to harvest things? What areas are just going to be managed on foot with hand tools, machete, pruning saw, clippers? Building almost a network to be able to access every part of your property. You can almost imagine it as like a fungal network of like, you have the main superhighways, but then you have like, you know, the minor pathways, and then you have the really small areas. So you can access everything really efficiently. That's what you're aiming to do, is mainframe design so you can access everything efficiently with the right tools and equipment, anticipating for future needs. Number 5 on the scale of permanence, things to be paying attention to, is trees. There's so much to deep dive with trees. We're not going to cover all of it here. But you're looking for 2 things predominantly. You're looking at existing species that local growers are producing, like edible crops. That's really invaluable to pay attention to. What are other people who are involved in gardening, permaculture, agriculture, tree crops? What are they growing? What are they having trouble with? What are they doing successfully? What can they just put in the ground and grows like a weed? What are they struggling with? Right? That's research. That's data for you to collect. I can't stress this enough. Go spend time with other people who are already in your area, who've been growing there for 10, 15, 20, 30 years. It's going to be invaluable information. It's also going to be a great source of seeds, cuttings, plant material. So that's part 1 of existing species. Part 2 is the weedscape. What is a weedscape? If you're new to this idea, in Syntropic Agroforestry, right, we talked about how these early pioneer species are sometimes considered weeds, right? Sometimes they're even like invasive species classified as that. But understanding your weedscape is understanding what trees do really well in your area without bias, without looking at a species and saying, oh, that's a bad species. Well, it just is. And more than likely, if it's classified as bad, it's just really good at doing its job. It's part of that restoration or that repair sequence. And so what you're doing is, to assess your weedscape, is you're looking around your local landscape and seeing what species are thriving on neglect. Nobody has to take care of them, no fertilizer. Nobody even probably has to plant them. Maybe a bird hoops a seed out, or maybe a seed just gets blown in the wind or falls off something. What are those species that are spontaneously just doing really well in your landscape? Weeds, the fast-growing trees, the fast-growing shrubs, the ones that are on the roadside, on fence lines. A really great place to look is the railroad tracks. Alongside the railroad tracks that don't really get managed, what species are there? It's a whole library. It's a whole collection of weeds. Go explore, see what works well, see what things are growing, notice the patterns. Once you spend some time in a landscape, you'll be able to really see. It stops going from like just green that you're seeing, but you start to see the patterns and see these different species and what they're contributing to the space, how they're moving that succession forward, what space they're creating. Maybe a bunch of them are nitrogen fixers. Maybe there's some fungal bridge species in there, like poplar, willow, alder, the nitrogen fixers, all the acacias, right? What's your local weedscape? So looking at fence lines, looking along the railroads, even looking at abandoned old houses, right? Or abandoned sites that haven't had any activity or any management for years. There's going to be a pretty great library of the weeds of your local area. And like I said before, looking at local growers, right? Go to local farms, local orchardists, but also visit local permaculture people. Without a doubt, there's people who have been practicing permaculture in your area for longer than you. Go learn from them. They have so much information to share, so much knowledge, so much practical wisdom. And you'll get a really good idea. You'll get really good feedback of what species work well. What are they growing? How are they doing it? What's working? What's not? Between these 2 strategies of looking at local growers and the weedscape, you're going to come up with the most epic library, probably more diverse than your average grower, because you're going to be incorporating the weedscape plants. You're going to be incorporating those early succession pioneers on top of what all the local growers are doing in their gardens. You're going to come out with a really epic collection of plants, an epic genetic library, right? Of what's growing deliberately, right? And the pioneer species, your weedscape, is going to show you the blueprint for how do you reforest this landscape, because they're already doing it. They're already showing you, they're giving you the template. And so by combining these 2 things, these 2 different successions of species, right? Because you might come across some fast-growing weedscape species, some secondary species, right? Those fast-growing trees. Maybe there's even some climax things from your native ecosystem that the weeds are supporting. They're creating the conditions so that you see some seedlings of what the native landscape would be. What you're doing is you're then combining these to create the most incredible succession. That's how you're doing it. It's really that simple. Go to local growers, assess your weedscape, combine them both. It's that easy. So that's a big part of how you're looking and reading the landscape of trees, and specifically the existing species in your landscape. Like if you visit all your local growers within a 10, 20-mile radius and do the same thing for the weedscape, like just do a really radical assessment of what's growing here, you're going to come away with like the most incredible library for your agroforestry system. So that's trees. Number 6 for the scale of permanence is soil. Now we could do a whole masterclass on soil. I'm going to try my best to give you just the most condensed and relevant things from my own personal experience. There's 2 components. There's kind of the parent material, like the composition of it structurally, and then there's all the biological side of soil, right? The nutrient cycling. How does this connect? Well, the parent material connects to all of it, right? That influences everything, whether it's sand, silt, clay, what kind of loam is that. The nutrient cycling side of things is more interesting to me. We're going to dive into both. So nutrient cycling is everything. What we're doing in agroforestry is we're accelerating and we're facilitating nutrient cycling nutrients within the system, right? Here's what's involved in that. You have trees, they grow, you prune them. Because you have a diversity of trees, you have a diversity of material. When you have a diversity of material, you have a diversity of biology underground, right? Because not every organism wants to eat the same thing. You also get a diversity of biology happening underground because you have a diversity of root systems underground, right? That's a huge component of this, is that the diversity of root structure and root systems underground is a huge contributing factor to all of this, right? Different plants pump out different sugars, different exudates, right? They exude different like things into the soil to feed certain biology, microbes, fungi, bacteria. That's why having a diversity of species is so key. So you can feed a diversity of organisms in your soil, because the research is that's what the research is showing, is that it's not this like chemical approach to soil. That's what like the NPK chemical fertilizer industry has kind of sold us, is that it's just about the raw chemicals. It's so much more about the biology. Everything your soil needs is there. It's in the soil. The nutrients, it's there. What's missing is the biology, the life in the soil. And so how do we put that as our goal, right? Rather than like trying to just have a healthy crop as our goal, it's like, how do we have healthy soil? Because that's going to support everything that we need. So we get a healthy soil by having a diversity of plants pumping life into the soil, right? Our collection of what other growers are doing and what's in the weedscape. If you get those, you combine them, you're going to have this incredible collection and diversity of material on the surface of the soil. It's being able to be decomposed by these fungi connections, and a diversity of symbiotic relationships underground. All right, so all of this is working in tandem. It's working together, right? You're pruning, creating these growth pulses, these hormonal exchanges, all these root exudates from diverse species, feeding a diverse microbiology, right? It's like a gut biome. If you only eat pizza, your gut biome turns into a monocrop of pizza-loving gut biome organisms, right? That's not a diverse, healthy system that's resilient, right? You want to be able to access and unlock all these different kinds of nutrients to be cycled. So that's kind of more of the living component. Obviously, there is the structural side of things, where you've got, whether it's some kind of combination of sand, clay, and silt that make up your soil composition. This is like a parent material conversation, where your soil is constructed by whatever the material is that it originated from, whether it was a mountaintop or some combination of geological forces that created the soil that you have. Right. And so in terms of like physical structure, sand particles are the biggest, right? You can feel the texture of sand. You can't really feel the texture of clay, right? slippery, it's slick, it really the smallest, like super tiny particle size compared to sand. Right? Silt is somewhere in the middle. Some of the key components here, because sand and clay are so different, they have almost like these complementary and opposite dilemmas that they're dealing with. On the clay side, what you're trying to do is compaction. You're not trying to do this. Compaction is something that people are typically dealing with in clay soils and clay conditions, right? So you're trying to not just undo compaction, but you're trying to reduce it, right? Not just reduce, but trying to undo, right? And that can be done with two things: biologically and mechanically, right? You can undo compaction. On the sand component, compaction isn't as much of an issue as much as nutrient and water retention. Like if you have really sandy soil, the water just drains immediately. Nutrients are very quick to go, right? It's a lot more porous. It just, things filter down. And so you kind of have different problems, especially when it comes to, or different opportunities when it comes to water, right? In clay, you're typically trying to improve drainage. With sand, you're trying to retain it, right? You're trying to reduce drainage. You're trying to hold on to water. So part of that means like getting a bunch of organic material in the soil, creating those fungal networks, fungi. The mycorrhizal fungi in the soil holds on to so much water. The answer always comes back to like growing more things, having more organic material in the soil. But you're trying to, with sand, improve nutrient and water retention. That's done by adding organic material. With clay, you're trying to reduce and undo compaction. Biologically, same thing, grow lots of trees, put a lot of organic material into the ground in that way. You can also do it mechanically, right? We'll talk about some of this during the installation module, but you can do that mechanically with a subsoiler, right? If you have really compacted ground on your tree lines, you can rip a deep trench to bust open that pan, that hard clay pan. So those are some of the complementary and different dynamics between clay and sand. You can also do other things like adding lime chip or adding clay in sand, right? Lime will help to break that clay up. Adding clay into sandy sites will increase retention of water and nutrients. So there's these different strategies you can play with depending on what you've got. Experimentation is huge. Try things, right? There's no one silver bullet. A loam, just to cover it here, something in the middle, right? Some kind of combination between sand, clay, and silt. So I wrapped up with soil as the last component of the scale of permanence. There was a couple that I skipped. I skipped animals and I skipped structures. You can learn about that when it's more relevant for you at your own time. This is mostly as it relates to food forests and agroforestry. We had climate, landscape, water, access, trees, and soil. So hopefully that was useful in terms of creating kind of a framework of what to prioritize and give your attention to when you're in that observation mode, right? When you're going out into the landscape and you're doing those initial plannings for your agroforestry. Now, this has been some of the highest level design framework stuff that we're going to look at. As we go, we're going to start dialing into more and more practical details. If you're enjoying this, I've just started a free 30-day email series on different lessons since starting my food forest design business. Sign up below if you're interested and you're on that path yourself of getting into consulting or running your own food forest design business. All right, this is the design process layout module. So we're going to be exploring different layout formats for your tree lines, alley crops, nests, things of that nature. A lot of this is predicated on the fact, though, that 95% of your work in agroforestry and food forest is management, right? It's this common frame, common saying, common understanding that the design and the planting of your system is only 5% of the work. And because management is 95, like management's everything. So that's what you're designing around. You're designing for management. You're designing for efficient and effective management. So you're looking at two things when it comes to management. You're looking at the design of your target crops. What are you aiming for? What are you harvesting out of? And the equipment that you have to manage with, right? So whether you're looking for timber crops or nut trees, whether one of your crops is animals, fruits, vegetables, that all ties very directly into management. Along with what equipment you have. Do you have tractors, rotary hoes? Do you have brush cutters? Just hand tools? These are all conversations that influence what does the management look like of your system. And ultimately, that's what influences the layout, the design, the plan that you put together. One of the things that I've noticed over the last number of years are these patterns that emerge and establish, right? This is a classic framework from permaculture, kind of mixed with agroforestry, something that I've seen a lot of. So we're going to dive in to see how things change at what scale, right? If you're a backyard gardener versus if you're doing some massive reforestation, or you're doing some large silvopasture, or alley cropping of vegetables, berries, tubers, or medicinals with trees, right? There's all these different ways you can play with this at different scales. And so I'm going to highlight and outline a few of them. In permaculture, this is your zone zero, your home, right? Where you spend most of your time. And in permaculture, this kind of extends on a scale from 0 to 5 with basically level of involvement, right? It's not dissimilar to what we're going to look at here. What we're going to look at, though, is more specific examples of how that's applied. What I see as a common practice immediately around the house are nests. If you're not familiar, we're going to dive into what that means, but this is where I see these applied most often. Food forest nests. They're these cute little things, and they allow for a little bit more organic feel right around the house. So you don't have big, strong lines breaking up and dividing a landscape. They can create a really nice organic flow and just be a really special spot for those certain species, maybe a special tree that somebody gifted you, or just really special or rare plants that you can't or don't want to lose in your agroforestry system. So right around the house, nests. This would be kind of like a zone 1 in permaculture. Then what a common pattern you see is because things scale out, because you need to become more efficient with your time as things grow, you see the strategy of lines, of tree lines becoming adopted, right? Tree lines and maybe with alley crops. So the combination of tree lines and alley crops is mostly just due to the fact that things scale out. You need to be more efficient, but you still want that diversity of production, whether it's fruits, vegetables, berries, herbs, medicinals, plus your fruit trees, plus any other trees that you would need. Still kind of close to the house. We're going to explore and explain what all of this means, just giving you a high-level pattern. Then a bit further out, you have larger scale, right? Maybe you have bigger grass in between your rows that, maybe you're cutting the grass and feeding that into your tree lines, or maybe you're doing silvopasture. You're incorporating animals in between your tree lines. So these two strategies here, maybe zone 2 to 3 and 4 in the permaculture zone frame. What you see at the very, very back end of that, it almost cycles back to the front. We see a strategy of nests being employed. This is for really, really large scale reforestation efforts, especially in areas where machinery isn't able to get there, right? Maybe it's tricky terrain or it's just at such a scale where machinery doesn't make sense. One of the benefits of nests is that they're easy to do by hand, right? They don't really require machinery. You can do them with a couple people and some hand tools very effectively. And so this is a general pattern for how things kind of scale out from the house site into large reforestation areas. Nests, tree lines, alley crops, maybe then silvopasture, and then back into nests. And so we're going to dive deep and see what are the technical layouts and the blueprints and the composition for each of these. But first, starting right around the home with a base map and a sector analysis. This is kind of building on the foundation that we just looked at previously. where we're taking a look and assessment of what's happening in the landscape around us. What do we need to be paying attention to? At a fundamental level, the base map and a sector analysis is actually really simple. It's the foundation on which your design is built on, right? So if you have an empty blank canvas map, the first things you're going to put on there, obviously your house site, any terrain, any water features. Maybe there's a stream or a river, right? All the things that are kind of contained within the boundary. That's quite an important part of your base map. What are the features? What are the things that are existing? Maybe there's some existing trees or forest or vegetation. Then you're looking at your sector analysis. What does that mean? A sector analysis is basically you're looking at energy sources, energy flows, not in some like woo-woo energy kind of way, but really hard realities of like sun, wind, water, noise, pollutants, wildlife. You're looking at how these things external from your property do have an influence and how they interact with your property. All right, so maybe the sun, you track it and it goes from that side to that side. You're looking at what areas are sunny, what areas are shady at what times of the day. You're looking at where does the wind come from seasonally or on storms. Maybe seasonally it's quite regular from one side, but on storms it comes through very intense, or rain, big heavy rains come from one side. Maybe there's some noisy neighbors coming from this side, or some views that you want to block. Maybe you're bordering a wildlife sanctuary on the back, so there's some cool wildlife corridor opportunities. Or maybe you're neighbors with a dog kennel and there's constant barking, right? The sector analysis is just a more broad zooming out and seeing what influences are coming onto the site, onto the land, right? So you're layering that on top of a base map. The base map is just what's on the site: topography, slope, water, vegetation, structures, fencing. And then you're seeing how the external influences are interacting with those. So that's the foundation. Another component of how you're planning the layout and the design of your food forest, I call site matching. What that means is you're taking an assessment of what are the different characteristics of different parts of your site, right? So let's say we have our 1 acre section right here. We have a house in the middle. People love to say this idea that I've got a blank canvas. No, you don't. No such thing. There's no such thing as a blank canvas. And I can't stand it when people use that language, because that's assuming that it's like a blank piece of paper with no texture, no nothing. And no piece of land exists like that. There's always some kind of texture. There's always some kind of influences. No such thing as a blank canvas, right? Imagine you have that sheet of paper and then you put a rock on it. Suddenly each side of that rock, each face of that rock, depending on where the sun is coming from, depending on where the wind is coming from, it's affecting all these different things. It's affecting the wind patterns. It's affecting heat, temperature. So by having a house in the middle of your site, suddenly, well, if that's the sunny side of your house, then this would be the shady side of your house, right? It's warmer over here on that side. Maybe this side of your property in general is more exposed to the wind. This backside is more sheltered. Maybe your house is really hot, so you need some more shelter around your house to keep it cooler in the summer, but you want to stay warm in the winter. What you're doing here is you're matching the conditions of the site, right? So you're looking at what's happening on the site. Maybe this area at the front has certain characteristics. It's hot, it's windy, it's exposed, right? Up at that front area. Maybe out the back, it's sheltered, it's warmer, and there's less wind. Again, this is just an assessment of the characteristics. You could almost call this the landscape character map. I've referred to that in the past. A landscape character map is you're just looking at the characteristics across the landscape. And so this middle area here, it's got the house. Maybe it wants a little bit more shelter. You want a bit more shade in summer. Each of these different parts of the landscape have different things they want, right? And you're wanting to match the kind of food forest, the kind of plants that you put, the kind of systems that you put into place, match those with the characteristics of the landscape. And so, for example, if you've got kind of a moderated or a Goldilocks kind of climate, you might see this area out the back and think, yeah, that's because it's sheltered and because it's to the south or the north of, depending on which hemisphere you're in, but it's to the back of the house. There's no opportunity for it to shade, cast like really heavy shade on my house if we plant it with evergreen species. Evergreens typically being subtropical. And so if you've got this really nice sheltered and warm site, that probably suits subtropical plants because they're evergreen. You can let them grow big. They're never going to shade your house. Right. And so maybe the back area is matched to subtropical plants just because the conditions match. Maybe around the house, it's a little bit more exposed. It's a little bit more windy, but you have different requirements now. Now you want shade in summer to keep the house cool, create some nice outdoor spaces that are not just like roasting hot. But when the sun is lower in winter, you still want the sun. Well, there's a whole category of species that match that perfectly. They're called deciduous species. They lose their leaves in winter. They regrow them the next season in summer. Deciduous plants are perfectly positioned right around the house because they do exactly that function. In summer, they create shade. They cool the house down. They make it more livable. And in winter, they lose their leaves. They let the sun come in. They keep your house warm. And so typically, these deciduous plants work really nicely around the house. More temperate species, apples, pears, plums, figs, nectarines, peaches, persimmons, right? As opposed to our subtropical trees, things like bananas, avocados, macadamias, evergreen, heavy shade casting things out the back. So already we're starting to see how this landscape, even on a small level with only just a few patterns, starts coming together. And what about the front there where it's like, it was really hot, windy, and exposed? What kind of climate matches those conditions? Hot, windy, and exposed. Mediterranean, right? Perfect. We have a whole collection of Mediterranean plants that would love to sit up there and enjoy those conditions, rather than trying to force subtropical plants to suffer through those conditions, right? That's kind of on a micro level, what we were saying before in exploring the scale of permanence is you're adjusting your farming practices to the landscape and not the inverse. Same goes here. We're not adjusting, you're accommodating the plant species that you choose to the landscape and the characteristics. And so if you've got an area in your landscape that's hot, windy, and exposed, I would be looking at Mediterranean plants that are going to do well there. And so suddenly with just a few layers to move us beyond the blank canvas, looking at sun, looking at wind exposure, proximity to the house, it's just a game of relationships, this whole agroforestry thing. You're looking at what relationships exist between the different spaces and the elements. So that's called site matching. Dive deep and go create a landscape character map. Just map out without bias of like, this needs to be this. Like, just take an honest assessment of like what's happening across the landscape and then see how that overlaps with your own goals and what you want out of it. Hey, so inside the fellowship, we're hosting in-person training events all around the world, and you get tailored guidance on your project. If you find that helpful, check the link below. Fantastic. Let's look at nests. Nests are really, as we saw with the scale and the zones, they're a really great technique for planting a food forest. How do you do it? What does a nest even mean? So a nest is a circle where you would basically create a collection or a succession of plants, right? We looked at the succession of species already. Each nest would contain its own succession. So you're planting the fast-growing things, you're planting the short-lived crops, you're planting the medium-term and the long-term species, all in the same 1.2 meter diameter circle, roughly. Now, why is it 1.2 meters in diameter? So you can be kneeling on the outside and still reach the middle, right? You're on the outside, you want to be able to reach that middle point, and scale is off, but you get the idea. So that's the idea of nests. Now, how do you actually go about planting these incredible edible circles? Here's the pattern. In the middle, you're doing one of two things. One, you're planting a grafted tree, or two, you're not doing both, you're planting a banana. Now, the reason you wouldn't do both is because the banana is very extroverted and takes up a lot of space, especially if you're in an area where they grow very quickly. And the grafted tree wants a bit more space in that. So you're either choosing in the middle of your nest, the grafted tree or the banana. Essentially, your long-lived climax is going here. And so if you're doing a banana, then you would also maybe put a seed or a seed bomb, multiple seeds, for your climax community, your climax, your long-lived tree. Maybe you're putting a collection of nut trees or an avocado in the center of your nest. The next layer is kind of that middle area in the nest, not directly in the center, but just in the middle. That's where you'd be looking at your secondary community of plants. The ones that aren't going to be there in maybe say 30 years, but you're going to get some really great productive time out of them in the meantime. And so you could put maybe between, 2 and 4, depending on what species you're choosing, maybe 6 to 8 secondary species. And it could be a combination of trees and shrubs or tubers, right? Fast growing trees, shrubs, or tubers. The secondary species, the ones that are going to live between maybe 2 and 10 years old. All of those are going to be supporting and being a nurturing mother for that climax species in the middle. The last part of this pattern of planting nests is that outside edge. The easiest way to think about it is as you're moving outwards from the center of the nest, you're moving down in succession. And so this will be your early placenta species, right? Or it'll be your herbaceous support species. What do I mean? If it's your placenta species, that's where your fast harvest vegetables are going to go. Radishes, lettuce, maybe corn. But ultimately, that's where your faster harvests will be on top of any herbaceous support, right? Anything that you're regularly going to be chopping and dropping and pruning to support the nest, that's going to go more on the outside. So you're never really going to be in danger of swinging a machete and chopping your highest value climax species in the middle, whether you're using a machete or a brush cutter. So that's the rough pattern for nests, is as you move from the inside outwards, you're moving down in succession, from the long-lived down to the short-lived. How it looks on the ground from a plan view, right, looking on its side, looks like this, where you've got your maybe 2 secondary, or you've got your 2 climax species growing, sandwiched in between 2 fast-growing shrubs. And you've got your maybe placenta 1 and 2 species coming out the side. Maybe they're your roots and tubers, plus your early fast succession of vegetables. Beyond that, what you're doing is anything outside the nest is just the existing vegetation. That's the beauty of nests, is that you don't need to do these massive cultivations. A lot of the syntropic agroforestry sites that you see are huge, are after a huge effort of cultivating a large area. If you just have hand tools and you're trying to cover big ground, this is probably a really great strategy for you. You can dig a nest, throw your species in, they're going to work harmoniously together in community, rather than if you just spot isolated planted all these trees around, there's value. There's like so much value in them being together in this nest, right? They communicate, they support each other. On top of that, you can use this existing vegetation that you're planting into as pruning, right? If it's grass, on whatever pruning interval you come through, you cut the grass and you use that as organic material as mulch to support the nest. You're placing that organic material on the outside edge right there to build that differentiation between the grass and the nest. And so maybe if you're starting with already having a lot of organic material, this is where you would place it. You would place it in a ring around the outside of your nest, whether it's logs, branches, some combination of those and wood chips, a bunch of leaves, whatever you have access to, you're creating a really thick ring of biomass around your nest. What you can also do, let's say we zoom out a little bit, you can also plant specific biomass species in between, some really hardy pioneer species that are just going to provide herbaceous biomass between your nests. Let's say you live in a subtropical or a tropical climate, you can just plant Mexican sunflower or bana grass or napier grass into the existing vegetation and use that to support your nests. Now, the distance between them, right? I mentioned before that these are 1.2 meter diameter, roughly 3 meters between the nests. And why is that? That's because you do want to get to that stage fairly quickly where you're creating a closed canopy. All right, so let's say we have a nest here and here. You want to quickly get to the point where your tree species are creating as much of a closed canopy system as possible. All right, because that's where you're going to really create that forest effect. Right? You're going to create that increased humidity, depending on when you're wanting that for pruning cycles, certain fruit tree crops. If you start to spread things out a lot, it can still work, but you're going to reduce its ability to like quickly accelerate into that forest ecosystem. You're going to have less material to prune. Make use of the space in your efforts. 3 meters roughly between these nests. Fantastic. Anybody in the live chat? Anybody in the Zoom call? Questions about nests that I've not answered?
One question. You never putting organic material in the nest when you start in the nest?
If I was, it would just be like light, like it would be grass. I wouldn't be putting like heavy organic material in there, especially if like seeds are wanting to come up and tubers and being harvested and things like that. Really, I'm prioritizing the organic material being on the outside and just a light covering on the actual nest itself. But really, that nest is going to pop off with photosynthesis so quickly with how much stuff you're jamming in there that there's not actually, if you're doing it well, there's not going to be a lot of sunlight to be hitting the surface of the soil there.
Yeah, true. All right, perfect. Thank you.
Yes. Great question. Other questions about nests?
From a temperate perspective, you kind of want an emergent layer as well with your temperate fruit trees like your pears and apples who kind of prefer that high level. Would you be looking at putting the emergent species like on the outskirts of your target species? Or like how do you reckon it would be structured to kind of have your support species that provides that the emergent layer versus the target species, which is a high strata layer?
Yeah. I would, if you're asking like, does it go in the nest or does it go out of the nest? I would say certainly in the nest, or is that what you were asking about, like positioning of it?
Yeah, just positioning like within the nest. What would that look like?
I'd be inclined to put the support like closer towards the middle, right? Because I wouldn't want to accidentally like be managing and cut it down because it was on the outside edge. I'd be inclined to put it somewhere towards the center, because it's never going to become so overbearing that like it causes everything else to suffer unless you're slacking on your management. Like if you go away for 2 years and come back and you're wondering why it's, overpowered things, you're like, oh, well, maybe it's because I didn't manage it. But if you're managing your system, if you're pruning it at least once a year really heavily, then it's going to be great for as long as it needs to be in that system.
Cheers.
What I've also seen is that I'll draw it here. I've seen this too. You could have a nest of like where you're like most of what's in here are actually the edible species, and then your support, maybe you do a support nest of like 2 support trees here, or maybe you do lines of support trees. Right? There's so much flexibility and creativity to how you can approach this. You can do lines of just like really hyper dense support trees or non-edible trees, non-cropping trees, and that would simplify. And maybe you could relax a bit more on the management if you just had like dedicated every 5 or 6 meters, you had these lines of support trees, right? Service species. And then in between you had islands or nests of edible species. And then within that, right, it kind of almost would mean like you're acting with alley crops of nests and herbaceous supports, and your tree lines become support trees. There's all these different ways you can combine this stuff. Really, it's about your context, understanding like what kind of management you want to be doing and have the capacity for.
So, yeah, this is what I'm always curious about nests, because especially I have a lot of homeowners that come, people like just at a smaller scale, and I'm always trying to figure out how to guide them through the nest because I'm more top on linear planting. So with the nests, like say if I want to have avocado, mango, banana, eucalyptus, just throw some species. Can I plant the eucalyptus and banana in one nest, and then the mango and the avocado is its own nest, along with some of their pioneer species in the beginning with it? But eventually that climax, like how are the climax nests looking at that point? That's what I'm always trying to grasp my mind about when it comes into nest planting, especially at a smaller scale where you don't want to do linear planting.
Yeah, love that. I got the opportunity to see Ernst's daughter's systems, her nests that were like right by the house had been highly managed, and they were about 8 to 9 years old when I saw them, and it was incredible. It was a very non-linear feeling, but you could actually see if you're paying attention, like, oh wow, there's like nest patterns here, and like there's some nests that have just been like fully consumed by the system, or bananas were cut down and just allowed to rot into this like juicy material after 8 years. But it had this very much still organic flow. And yeah, basically what you said is exactly how I would approach it. I would be planting, maybe seeds. Like as long as you're doing non-grafted climax trees, you can plant them with bananas. I just wouldn't pair like the grafted tree with the banana in the same nest. But yeah, just other than that, like throwing everything in there together, especially if it's, depending on how good of access you or your client has to plant material, like just load them up with more seeds than they'll ultimately want to be growing there. So you get to choose whichever ones are best.
And you can just also keep those nests separate. It's like here is like kind of going off that formula that you mentioned earlier of like emergent medium nests plus that high low nest as well. Like, is that
so you could be
fairly
alternating?
common? Okay, cool. Thank you.
Yeah. Yeah. Not every nest needs to have like the full massive complexity. I like to go in that direction. Like I don't do the A/B lines because I just like to throw it all in and like see what works, right? Because I think that that's the stage that I'm at. I'm at that very experimental, but then also consolidating and figuring out, refining what does work. But to get there, you do have to be very experimental. And so I think that while it's all good and nice to say like, yeah, tease them apart between like your A lines or B lines, medium, emergent, low, high. If you don't know, if you don't have any experience with agroforestry, you're going to kind of be like shooting your shot in the dark. I would recommend just going like very experimental, like put it all in, knowing that, especially if it's from seed, like maybe be less experimental if you're spending thousands of dollars on grafted trees. But if you're just being experimental and you have good access to seeds, throw it all in. That's where you learn. Make your observations like that and then refine once you figure out the patterns.
And just to confirm, when you're talking about throw it all in, you're not talking about just throw it in all dead center. You're kind of throwing it in within a certain like at that close towards that center point of that nest, correct?
I kind of like things to be consolidated. I don't want like even within the 1.2, like a 1.2 meter nest is like this. It's not that big. I still
Yeah.
don't want things popping up like super randomly between, like I kind of do want them consolidated towards the middle.
Okay.
Especially if there's not a banana in there, man, I'm pretty aggressive with like how tight I'm putting these seed bombs. But again,
Cool.
that's also a function of like access to seeds. Like if you only have two special seeds of the, okay, well then like, don't put them right on top of each other. But if you've got good access to seed, which you should, that's the job of every agroforester, is like collect seeds, get well connected, source them. That's why I'm saying go visit your local growers, scour the roadsides, like get big abundance bags of seeds so you can have the freedom.
Awesome. Thank you for sharing.
We've got an interactive map feature inside the free Food Forest community, the Food Forest family, where you can connect with other Food Forest practitioners that might be right in your local area and you just have no idea about them. So go join the Food Forest family if you're enjoying this. All right, we got tree lines. So we just came from nests. We're going to dive into what is a tree line. We've been talking about it. What does that actually mean? How does it look? How are they structured? And why do you do it? So a tree line is probably the most widely seen thing in agroforestry. Most sites are planted in tree lines for the major reason that it's the most efficient way to manage a complex system, right? You're trying to create complexity, but also order within that so you can manage it well and effectively. Because management's everything. If you can't manage your system, you're going to neglect it. And if you neglect it, it's going to turn into a sour system, a system that you don't like even thinking about or being at. Then you're going to ignore it even more. And then it's going to become this overgrown mess that you don't even want anything to do with. And you're going to think that agroforestry sucks, it doesn't work. And that's not what we want. We want you to love agroforestry. And so planting in tree lines makes management way easier and efficient. Here's how they look. You can have a diversity of species in your tree lines. It doesn't mean just trees. You can put annual vegetables in your tree lines. You can put roots and tubers. You can put berries, herbs, medicinals, fruit trees, fodder trees, right, for animals to eat, timber trees, nut trees, firewood trees, other support trees. Your tree lines can have everything. You don't even need to have anything except tree lines in some cases. Now, sometimes you'll have an alley crop, which we'll discuss and dive into, but especially in the early stages, if you have a lack of propagation material, like if you only have two of these things, put them in the tree lines. They'll multiply there. They'll replicate. You can then expand outwards. So those are some examples of what you can put in the tree line. It's essentially just a straight line. I like to actually make it dead straight with a string, almost that exact, because precision really matters here. We'll explain why. But on the surface, if you look at kind of like the side and the top-down view of these tree lines, you can see that when you're in the planting stages, you can see there's almost like regular spacing between certain species, right? So that's kind of what we're aiming for, is to identify some patterns, right? Why might that be useful? Partly it's useful to know, how much space do we need to include between each tree, right? Maybe between our emergent layers, our medium layers, our low, our high canopy trees, right? How many trees do we need to fill a space, right? Maybe if you have 20 meter and you have 3 tree lines to do, you're going to do a little block, 20 meter of 3 20-meter tree lines. How do I know how many trees and plants I need to get? Part of what you're looking at is you're looking at what's the interval between some of these different species, right? How frequently do I need to put a raspberry in here? How frequently do I need to put a target fruit tree? How often should I be putting seeds? How often should I be planting a support tree? These are all great questions. It depends. Gotcha. The answer is that there is no one right way to do things. You experiment, you learn, you accept the feedback. That's the key thing. I made a big mistake in my first year of not planting densely enough my support trees. It was a terrible mistake. I've never made that mistake again. Since then, I've planted support trees at least every half a meter. Now I'm relaxing a little bit more and going meter, meter and a half. So you experiment, you play, you learn, you accept the feedback. At this stage, I'm planting support trees every meter and a half. And within that, I'm either planting a banana and a bunch of other things by seeds and cuttings, or a grafted tree and a bunch of other things by cuttings and seeds. You'll figure out what patterns work for you. So I don't want to, I want to not overstress this. The layout is important, yes, but don't obsess over the details. Planting is more important than anything, because then you learn, you accept the feedback, and you see what you need to do differently. As a general rule, if you're doing grafted trees of some variety, right? Let's say you bought a bunch of grafted citrus or plums or avocados, pears, persimmons, whatever they are. My guidance for the grafted trees is take commercial planting density and move them a little bit further apart to allow for the higher diversity between, whether it's support species, whether it's other crops. I wouldn't take conventional orchard spacing and leave them there, because that conventional orchard spacing is generally aimed at maximizing canopy space for just that one species with that one life cycle and one strata layer. Right here, what we're trying to do is we're trying to almost like if you removed the middle two and then added your other diverse species, right? And so what you're doing is you're playing with that density. You're playing with how much light do these things need? How much room can I fit other trees in? And this is what we're looking at. We spoke of this before, the alternating A-B lines, right? Maybe combining high strata and low with medium and emergent. If you don't have a lot of experience with agroforestry, I wouldn't recommend that. I would recommend starting off by throwing almost everything into one line and making your observations. That's where you're going to learn the most. And more than likely, you can afford to do that in that your livelihood does probably not depend on this working, right? If it does, you probably have more experience that can be useful in guiding how you organize these species. But if you're just experimenting, you're learning, and you're on this journey to just grow more food for yourself, your family, your community, be experimental. You have that opportunity. See how they react with each other. It's all about relationships. And then you can learn. Then you can learn how to tease these layers apart, right? So that's kind of the example down here for two things. One, experimental learning. What's the other reason you would combine everything into one line and not worry so much about over complexifying things? Animal fodder. If you're creating a system specifically to supplement animals, to create silvopasture systems, don't worry so much about all the strata needing to be perfectly spaced and aligned and having, it's okay. If the system is meant for animal fodder, throw it all in there. All right. So in a lot of cases, that's my recommendation, is throw a bunch of stuff in there. You can always prune things out. And that emphasizes access to plants. Learn how to grow things, propagate things, learn where to collect seeds from. Do that work. That's a huge part of what makes agroforestry accessible. So you're not spending $200 on some fruit tree that you can only get one of. Like, go source seeds, go talk to growers, buy fruits, eat the seeds, save them, put them in your system. So just another visual on that emergent, medium, high, low, and the fodder example. We've got our low, medium, high, emergent, all crammed together for the fodder, because ultimately it's not about the production of one specific crop as much as you just want a diversity of things to be growing together. I would actually just recommend this if you're just starting out, so you can make those observations and you can learn. Once you get some experience, once you get a couple years or a few years under your belt of observing, maybe then you can start teasing things apart more. But if you start with that, if you start by saying, actually, I'm only going to grow emergents and mediums here, you're probably robbing yourself of the opportunity for things to do well that you wouldn't try. All right, so that's going to be one of my guidance for plantings is, and we'll get to this, but be non-discriminatory. ND. Non-discriminatory about, well, I don't want this particular plant, and I put it in. that might outperform everything else. You have no idea. Plant it, see how it does. So that's the quick recap on tree lines. We're going to dive into that a little bit more from a technical point of view with the installation and the management segments. But this is just the overview of what is a tree line, what's included, what are some different ways to orient them, the different functions, right? If you're growing alley crops in between, which we'll get to next, what's the spacing between tree lines? That's a great question. The standard that I saw in Brazil was around 5 meters. That's because most of them were growing one of three things in the middle. 1, vegetables, 2, medicinals, or 3, coffee. So they're growing these things in the middle, in between. So that's why they have 5-meter spacings to allow for enough sunlight to come down and grow those crops. If you're not interested in doing alley crops, if you're really just interested in maximizing the space that you have with tree crops, maybe 5 meters is too big. Maybe you need to shrink things in. At my site, alley crops are not my focus. So at my site, I'm doing about 3 meters, 4 in some cases, but mostly 3. And that's just maximizing tree density, forest coverage. So that's tree lines. On to alley crops. And hey, if you want more food forest insights and business lessons that I've learned from being in the trenches for the last 5 years in my own design business, I've got a free 30-day email series. Find the link below. Tons of value in there. So we've got alley crops. Alley crops are the spaces between your tree lines. You can either grow crops there, you can grow biomass, you can grow grass, animals, all sorts of creative things you can do in your alleys. This is just another way of leaning into that principle of agroforestry, is maximizing photosynthesis, making good use of the space. And so you can see our example here, similar to what we just left off talking about, examples in Brazil and at my site of people growing coffee, of annuals, of medicinals, herbs, berries, all sorts of things, right? Ordinarily, if you've got 5 meters between your tree lines, that leaves you enough space for 3 beds between, right? This can eventuate into 3 beds of coffee trees, but maybe it starts off being 3 beds of growing annuals, right? You're growing a bunch of annuals. And this is something that I saw a lot of, is you're transitioning, and this is how I would recommend it. It's almost as if your alley crops have their own succession, right? So your tree lines go through a species succession, but so do your alleys. And maybe it's a little bit more simple, but maybe your first succession in your alley crops is vegetables, and then perennial vegetables, berries, and then into some short-lived or medium-lived tree, right? It's okay to put trees in, or shrubs in your alleys, right? Shrubs like coffee, guavas, blueberries. So we're looking at the succession of our alley crops and how that can be more interesting or complex than just annuals. Or you could just keep your alley crops as annuals. You can turn them into annual systems that then turn into biomass production systems that then feed your tree lines, right? There's so much creative freedom with how you choose to allow these alleys to evolve, right? You can grow grasses, you can grow biomass species like comfrey or Mexican sunflower or bonnegrass. You could just grow regular grass and have animals moving through there. We'll discuss options for that. But I want to highlight really the interesting portion here is that your alley crops and your tree lines can have different successional paths, different successional species. Makes you a really diverse and productive food forest agroforestry system. So this is basically what we've just looked at. Your crops can go from annuals into perennials, and your biomass species from herbaceous into woody, right? Herbaceous things, the things that aren't woody, right? We talked about the layers, transitioning into support trees rather than just support shrubs or grasses, right? Woody trees. You can also incorporate these biomass trees in your alley crops. I know plenty of growers who grow their support trees or some of their support trees in the alleys themselves, right? Because they think every line needs trees. The more trees, the better. Now, a lot of it depends on what your capacity is for management. But hey, if you can put support trees in your alleys and you can stand on top of them, go for it. So if you're also trying to include annuals or larger scale cropping as a bigger component of what you're doing, maybe you skip out every other tree line and you just have more sunlight for early succession crops. Maybe you just have like larger garden style beds that you maintain in between wider tree rows. So maybe instead of 5 meters, every 10 meters. More sunlight, more sustained production of vegetables. Depends on what your values are, depends on what you want. Maybe you want big berry patches, they need more sunlight, cool. 10 meters, tree line, 10 meters, tree line. It's flexible, but it depends on the goals of the system, which is why context is so important. Silvopasture. This is the incorporation of animals into agroforestry. It's a beautiful point where we learn how to manage these two really positive things in the environment to create a situation really ecologically that can't be done without either or the other, right? Here's what I mean by that. You can only generate so much natural fertility with grass without the use of animals. Having animals in your system helps to cycle those nutrients in a much more quick and accessible way to make things bioavailable, right? This is a direction that I've been learning a lot about in the last few months, especially. And so I'm excited to share what I've learned. Essentially, utilizing this middle area between your tree lines, whether it's 5 meters, whether it's 10, 20 meters. In typical agroforestry, it's been explained to me that almost because we're using this area to feed the tree lines, typically we're not feeding back into the grass area in between, the alleys, right? Typically it's kind of like an extraction from there to feed the tree lines, which we care about, which they're lovely, they're doing their thing. By incorporating animals in between your tree lines, you're giving fertility not just to the tree lines, but you're also improving the fertility of the spaces in between. Fantastic. So the area in the middle benefits. The tree systems also benefit because they get to be forage for brief periods of time. They get that pruning disturbance from the animals. Now, this isn't like go let your animals loose in your tree lines, but once your animals have filled their guts, have filled their rumen, right, filled their stomachs with grass, this is an important timing thing. Once their rumens are full of grass, you can let them browse for brief periods of time on your tree lines. They're not going to demolish everything right away, especially if their rumen is full. But they'll do that to self-medicate and to really like not fill themselves. That's what they're not doing. You're not allowing them to like fill themselves on your trees, but they're selectively eating certain things for the minerals and the nutrients, right? They're self-medicating. And so this idea shift, I think that Scott Hall shared this recently, was that fodder trees no longer exist. Your fodder trees are now, in a system like this, your fodder trees are your citrus, are your apples, your avocados, your peaches, your persimmons. By turning those into part of the system, they're getting their prune, they're getting their growth pulse, and they're basically creating those like bioavailable nutrients and minerals from the trees in your tree line, adding them back into the system in a bioavailable way by going through the animal, improving the system. Growth pulse plus nutrients and minerals. So this is a direction that I'm really excited to explore once I get back to New Zealand, incorporating more animals into my system there. I've seen some really incredible examples since traveling around, especially here in Florida, Costa Rica. the key thing here is just doing it in a controlled way where they don't just have open free access, but they're holistically managed, being that patchy disturbance, patchy and intermittent disturbance. I'm going to write that one down because that's what it is. Patchy and intermittent disturbance. Patchy in the sense that once they're on a patch and they disturb it, that area needs to be allowed to recover before it's seen again by the animals, right? And so that recovery time is dependent on, the natural fertility, what species are already there, what kind of levels of sunlight does it get? All these different things go into that. What time of year is it? But you're moving these animals in a way where you're paying attention to the recovery time of a particular block, right? And the more you can mob graze, like stacking animals into a tighter space, consolidating that, and then moving them to the next, and the next, and increasing the recovery time before they bounce back, the better, right? Now, this is an area that, again, I have a lot to learn. I'm new to exploring this silvopasture direction, but you can do this with animals in general. It doesn't have to be cows. It doesn't have to just be sheep, birds. You can create an agroforestry silvopasture system for any animal that you'd be interested in having in your landscape. Goats are not one that I would recommend, though, just based on what I've understood and had my own experiences with them. They will escape and they will find your most expensive tree, eat that one first, and then work backwards in descending order of how much you paid for it. So goats are a tricky one, but silvopasture is the direction that I think there's a huge space to be explored. Definitely, if you're doing it, share it, post it in the family, post it in the fellowship, share with us, because it's a cutting edge for sure. And I'm excited for myself to keep diving in and sharing more as I get more experience. But that's the basic idea, is incorporating animals between your tree lines. Silvopasture can be on the complex side, where you have like full syntropic lines plus animals, or on the lower complexity side, where you just have lines of like nut or timber or fruit trees. And it's not this big syntropic thing, but you still have animals grazing underneath trees. That's still silvopasture. Less diversity, less complexity, still silvopasture. So some ideas there. Here are more ideas, just animals that you could design systems for: chickens, ducks, turkeys, geese, rabbits, sheep, pigs, cows, horse, llamas, goats, bison. Haven't seen bison agroforestry yet, but I would love to. One of you guys is going to do it. Let me know when you do. So you can be really clever, creative with how you arrange this. There's some really great examples of silvopasture, these animal integration systems, on the farm tours of the school page. In the family, there's examples of pig agroforestry, dairy. It's fantastic. So go there, check it out. There's also chicken. Again, not diving into the details, but at a pattern level, huge opportunity in silvopasture. Questions about that for anybody here?
Yeah, have you seen people say they're about to move their mob on and they just take the fence down and let them into the actual tree line for like a little while and then get rid of them? Is that what they do
No,
in
I
some
think
cases?
the key would be you want them to like eat the grass and get full on grass, so they're not trying to like fill themselves with what's in your tree line. And you'd also still keep the fencing up. Thanks for clarifying that. You would keep the fencing up and you would just move it in so they can browse from the outside. So they're not like, you don't want them to pass through the tree lines. You still want these to very much like be like walls that are containing them, but they have access to browsing each side.
Yeah.
Byron, another question. Like, have you been in any agroforestry system that they have chickens actually in the agroforestry system, not moving them? Chicken or ducks?
Yeah, chickens, I've only seen like really poorly managed chicken. Well, I've seen both. I've seen like well managed chickens, which is, as it's shown here, they're not in the tree lines, they're in the grass alleys between, and they're moved. That's fantastic. Where I've seen chickens have free range and they're like able to be in the tree lines, it's terrible because they will just like scratch the shit out of your mulch. They'll move it, and it's just not a good interaction. Ducks are a lot less aggressive in the tree line, so that's part of why I'm really looking a lot at ducks and geese and turkeys for birds. But I would never trust chickens in my tree lines because they're just such mulch flickers.
Okay, good to know. Yeah, because I have chickens and I have ducks, and yeah, I'm just also like want to experiment like how to implement them in an agroforestry system. Then it's good to know what you've seen already.
Yeah, yeah. I would not be just free ranging chickens in my never would happen.
Okay, cool.
So Dakota Cohen's got some really good chicken tractors. So he's based in Canada, and he does like amazing chicken tractors. And all his agroforestry rows like are wide enough so that these tractors can go through. Sometimes there's them one apart or two apart. But yeah, it's a really cool system to use with the chickens. I was going to ask you, Brian, with regards to sheep, did you come across any kind of sheep agroforestry or silvopasture in South America? And how did that go?
Most of the sheep agroforestry that I've seen is actually in New Zealand, just because, being land of the sheep. And I haven't seen syntropic sheep. I've only ever seen sheep under like quite orchard style isolated fruit trees. But I imagine if you have the right fencing setup and they're respecting the fencing, that's basically the key of it is, can you set the fencing system up in place so that the positive interactions are happening without any of the negative ones, i.e. them getting into your tree lines and just making a mess of it.
Yeah, that's so we're in the planning stages of transforming open pasture into silvopasture. And that like the farmer said that that's the biggest thing is that he just doesn't want to let sheep in because the type of fencing that you then have to do is cost prohibitive. So with cows you can have a hot wire, but as soon as you've got sheep, you need to have full on fencing because the sheep will get themselves in there and they'll ring back any of your trees within, like that 2 year period. But yeah, we're exploring how can we do it cost effectively, and that we can have both because they both serve a good function for pasture regeneration. So yeah.
That's great that you guys are doing that. Once you find out, let the world know. Yeah, there's so much research to be done here. And that's the beauty of it is like, go do some research, figure it out, find ways that work and help push that cutting edge forward. That's part of what I'm doing is seeing all these different sites and trying to communicate the information and practice things on my own site. It's all in an effort to make this information more available and accessible so that other people don't have to go through the same trial and errors that we do. And so that's our work. That's the work that we have ahead of us, is figuring out how to do that in our own context because there's many other sites like ours that need reforesting. So that's the work.
Yeah, so cool to see that it's like no, like there's so many different contexts and it's not that much information about every context, and you can experiment and do a lot of new stuff that no one have done before. Really cool.
Yeah, that's the opportunity that exists here for all of us. Even if you think that everything's been done before and you're not doing anything new, you have so much opportunity to explore and do things that people in your community could learn and benefit from. There's a lot of really unique contexts out there. And so, yeah, just get after it, do it, create the living example, learn the lessons and pass those lessons on to the others in your community. That's how this all happens. And hey, if you're already doing consulting or teaching, the fellowship is also where I help other practitioners with their business and their client projects. Check the link out below. All right, species selection. So this boils down to two key patterns. A lot of them you've heard already if you've made it this far into the lesson. The two key patterns for species selection. One, your target crops. You think, right? Put that caveat there. Two is everything else. So you got target crops and everything else without discrimination. This is where you're pulling from your weedscape and local growers, right? Now I say you think on your target crops because you can have these ideas in mind. You can have these goals of this is what I'm going to grow. And maybe it works. Maybe if you do a really great job of observing and you do a great job and you have a good understanding of like exactly what your plan is, the things that you're expecting to work and the things that you are setting out to do eventuate, and it's all really successful. There are times where you have a plan and nature has another plan. The ecosystem has another plan. And that's part of why the focus, the emphasis on plant everything, plant as much as you can get your hands on without discrimination, right? Pull from your local weedscape, pull from local growers, try it as much as you can, these different things to see what works well in your area, in your climate, in your context. Those are the two categories. And it's really that simple. I don't want to overcomplicate something that doesn't need to be. You have target crops that you want to grow, and then you have everything else that you can get your hands on. Combine them both. Weedscape, local growers. It's really that easy. That's the end of this module. It's going to be a 30-second module. Target crops, and then all your weedscape trees. Like, learn the weeds of your area, learn the spontaneous things, collect as many seeds as you can. Even if you think, I don't really think this is going to do very well here, put the seeds in and then take the feedback. Don't be so assumptive. It's arrogant to assume we know better. Try it. I used to not, I used to think, cherries, where I grow is, cherries won't work well. We don't get cold enough. I tried it. Hey, look, actually they do grow. I broke my misconceptions. I tried the thing. Just try it. Don't be afraid. Be experimental. It's okay. There's a really great quote that I'm going to share from Josh Anderson. He said, "No tree moves faster than a chainsaw." And so don't be afraid of planting too many trees. You can always cut them down. That's part of agroforestry. And that's how you learn. It's how you expedite your own learning and your journey, is you overplant things, so you do have to prune them, so you do have to manage them, because that forces you to step in. And by stepping in, that's where you learn. That's where the doing happens, is where you become a practiced, experienced agroforester. So that's on species selection. End of that module. Hope you learned something good. See you guys in the next one. Installation, order of operations. Now, I like to describe food forest or agroforestry installs like this alchemy, right? Where you're taking this set of like kind of on their own, more or less useless things, right? All these ingredients that on their own don't have that much power. And you're combining them in such a way and with such an order of operations that it becomes this beautiful thing, this beautiful forest. By taking these like, on their own, quite useless items, you combine them and it turns into this amazing agroforestry. Really, it's the materials plus the protocol. So that's what we're going to dive into. On the installation side, what materials and protocol are we looking at? On the material side, here's what we've got: plants, inputs, and then tools and equipment. Now, on the plant side, seeds. That's number one. Like, if you can get just massive amounts of seeds, that's the best. Like, plants grown from seed are going to be more resilient than any grafted tree or any transplanted seedling, because they'll have grown the whole time, their whole life in situ, where they're going to live the rest of their life. But obviously, not every single time you can plant a system entirely from seed. Doesn't always make sense, but they do create really strong, resilient trees. Now, we've got seeds, grafted species, seedlings, things that you have grown already in a nursery system, for example, things that you've grown from cuttings or just direct cuttings. And you have tubers and roots, right, on the plant side of things. You want to have all your materials organized when you come in for your install. On the inputs side, right, things to either amend the soil or to use as organic material, you've got compost, manures, worm castings, biochar, and then rock dust or organic material, right? Organic material is a very important one. You can start systems without any other inputs. Depends on the context. Not every system needs massive amounts of inputs. If you're not doing like heavy feeder vegetable-based systems, if you're doing like slow release, or if you're doing an accumulation system where you're only really planting the rugged, tough, low demand pioneer species, your input demands change. the two bottom ones, or the three bottom ones on inputs, clay, scoria, lime, right? Dust. Those might be if you're trying to change or amend certain soil types, right? So if you've got really sandy soil, we talked about this before, I've added clay lining almost under like as trenches underneath the tree lines to help retain moisture, nutrients. Versus maybe the opposite you'd want to do if you have really heavy clay. If you need to have more drainage in the soil, maybe you include scoria, which is like a really porous rock, increases drainage, right? You're kind of playing with what needs are there of the conditions of the soil and what are the demands of the system. In terms of tools and equipment, one of the biggest life upgrades that I had was getting a little rotary hoe, right? It made installing tree lines so much easier rather than having to like hand dig anything. It's fantastic. A little rotary hoe or a cultivator. You can also use a tractor if you're doing things at a bigger scale or if you have access to the equipment. If you have access to a subsoiler, that big single hook that goes into the ground and it breaks that pan up, it decompacts things, that's fantastic. If you can rip a line where your tree line will go, because then it just makes everything, all your trees that germinate in there, they're going to be so much happier. They're going to be have such an easier time working their way into the subsoil if you have that rip line done mechanically. Another big upgrade I made was getting an auger, right? You can either do the big gas-powered ones or a small electric hand one for smaller plants. Made a really big difference in my own life doing all these installations, not having to manually dig all the holes, but just very quickly moving through, especially once you start doing things at a bigger scale. One of the other really important pieces of equipment, I'm going to highlight this one, is a chainsaw, because we haven't spoke about it yet, but we're going to get there. Managing the existing organic material, managing the existing vegetation around your install site, super important. If you're paying attention to the beginning when we talked about the disturbance regime of agroforestry systems and the growth pulse, this is why it's important. You want to manage your existing vegetation right before the install. So having a chainsaw makes it invaluable if you've got existing trees around. Similar with a brush cutter. It's really nice to be able to manage the existing vegetation, the ground cover, before you go into install, before you get things tangled up in tall grass. And then having a spade or a rake, just really useful things to have on site to install with. So those are kind of your materials. Let's dive into the protocol, the actual installation procedure. Here it is. So step one for your install, prune and organize the existing vegetation, the existing organic material. Let's say you've got this site right here and you've got a little clearing and you want to grow your agroforestry there. But at the moment, there's trees on either side. There's existing vegetation. There's this idea in agroforestry and plant physiology that these trees are stagnant, right? This, we've talked about this. They're in their stagnant stage. They're not vigorously growing. They're not getting heavy disturbances. And so you've got these like big stagnant influences happening right adjacent to where you want a vigorous system to be planted. What you want to be doing is you want to be, before you plant, that's the key part here. Before you plant, you're pruning these stagnant vegetative systems, right? And maybe it's a really aggressive prune, because then guess what? Then you've got all this organic material that you make a pile with that you just pruned. You're resetting the hormones, right? You're resetting the growth hormone. You're creating organic material. Do this work. It's super important. And you don't want to do it after the fact, because maybe what happens is if you do it wait till the end, depending on how these trees and everything is organized, you might be planting underneath large trees. And so if you plant your system and then you realize, even if it's a year later, you're like, man, I really do need to prune this tree. You're going to prune this big tree on top of your system, and it's going to fall and break young plants. So do this do the heaviest pruning before you plant your system. Now, when it's organized, right, you're pruning, but also organizing the material. This is important in terms of the different texture and sizes of organic material that you're going to be using. right? Depending on what you're pruning around, you might be left with some like really big logs, right? If you're taking some large trees down. You're also probably, if that's the case, left with a bunch of branches, right? And so you might have seen in agroforestry having these like wooden log pathways or using branches for pathways, right? It reduces compaction. It is a really nice place for organic material to rot down into soil. The roots of the trees eventually find their way and feed on that. It's fantastic. Part of that work happens and is allowed because you've done this in advance. You've pruned and organized the material. And so part of the work is pruning to reset the growth hormone, to get everything in sync on the same page, because ultimately with the growth hormone, these boundaries are going to be regrowing at the same time and in sync with your own system. And so it's almost as if from the get-go, your food forest system is actually bigger than that. It's being incorporated with the surrounding vegetation. Do that. And also organize the material so that when it's all planted and then it's time to begin mulching and applying the organic material and adding it, all your big logs are over here, so you know how you're going to use them. You can use them at once. And then you're going to go to your smaller material because you're stacking things from the most coarse to the least coarse. We're going to get there. And then at the end, you're left with maybe these big piles of whether it's branches or ideally, you've got all these branches that they're not these like uniform size branches and logs, but all the twigs, the leafy ends, things like that. Hard to use. Maybe you just sent all that through a chipper, right? Making the most of this installation, the organic material. You've got big logs, uniform size logs, and everything that doesn't fit into those categories through the chipper into a pile. So then you've got 3 groups of organic material of different texture. That's fantastic because then once you plant everything, then you can go and organize it. We'll dive into the details of how do you organize the organic material, but step 1 is that you're pruning the surrounding vegetation and organizing the material. Maybe also you have some grass that you've cut, right? So make a pile of grass. All of the different kinds of material, organize that into different piles, so to speak. Step 2, prep your soil. We've talked about how you can do this. You can do this manually with a hoe, right? Not as fun that way, definitely possible. You can do it with a broad fork, right? It's these like market garden tools. That's not really what they're for either, but you can very much use it like on where your tree line will go. You can stick the broad fork in and you're basically like walking it backwards, teasing the grass apart from the soil. That's one way to use it. You can also use the rotary hoe or the cultivator. This is what I prefer. Fantastic, really efficient. You can also use the tractor. Good. Hope you guys like my tractor drawing skills. A tractor with either a cultivator and or the subsoiler, which is basically like a big hook that it goes down maybe like 75 centimeters, maybe a meter, and like just drags this hook through, busts that clay pan open. So there's a few different ways you can prep the soil. Basically what you're doing is you're trying to cultivate it. You're making it nice and loose and decompacted and fluffy. And you're also removing the existing vegetation, the grass, right? Any of like the physical roots and the weedy stuff that might just like immediately regrow. So step 1, pruning and organizing. Step 2, the actual soil prep itself and the removal of especially like grass roots that would be tenacious and more likely to reemerge within your tree line. Because you don't want that. Nobody likes weeding a tree line. Nobody does. So do this work to prevent yourself from having to do worse and less fun work. Let's see. Step 3, add your inputs. So let's say this is your tree line access bed. Let's try that again. Tree line access bed, alley crop bed, and another tree line. So if you've got your tree lines right here, we'll draw a little tree. and you've got your alley crops, right? You're going to distribute whatever inputs you have in accordance with the demands of that space, right? So I wouldn't be adding any inputs on the walking path. That'd be dumb. You're adding whether it's your compost, your biochar, your manures, to reflect whatever the needs of the space are. Maybe you're doing nests, right? Adding the right amount of amendment to the area according to what it needs, right? Maybe if you're just doing an accumulator system, it doesn't need anything. Maybe if you're doing annual vegetable production, you need a lot of compost. One of the things about this is, how much do I use? The answer that I've been told and I tend to go with and I tend to pass on is, go with your intuition. We're smart creatures. Our guts know, right? Use your intuition. This is a very intuitive practice. That's why a lot of this stuff makes sense. If you've noticed in agroforestry, is a lot of these ideas, these concepts and frameworks and techniques, they just make a lot of sense, because these are practices that we've been doing for millennia as human beings, interacting with the forest ecosystem. So use your intuition when you're adding your inputs, and prioritize where they want to go. You don't want to put it in your axis. You want to actually like very clearly layer it where it's needed for whether the tree line, whatever, alley crops, etc. Apply them thoughtfully. Stage 4, plant your big trees. Plant your bigs. Here's what I mean by that. If you've got your tree line, right, let's say you've got your bed here. The first thing that I like to plant are big things, not things that will become big trees. I'm not thinking like avocado seeds and chestnuts and nut trees, and I'm not thinking like that. Physically big things. Like if you've got large grafted trees, or if you've got big banana corms to plant those first. Like plant the large things first, so that down the line, when you're adding smaller things like seeds or cuttings, you're not digging those out to put big stuff in. So put the big stuff in first, and you work your way down. So grafted trees, banana corms, space those out appropriately for whatever your layout is, and then plant the big stuff first. Bury them. Maybe you mark them. Maybe you put a little stick upright where you've planted underground banana corms, so it's easy to see. But plant your big stuff first. The second thing you're doing, then you're going back and applying that mulch that you organized. Right? Here's going to be a quick drawing for how that wants to happen. You want to put your largest, most coarse material on the bottom, in contact with the soil. So you want to cut the logs and the branches up so that everything nicely sits in contact with the soil. What you're trying to do is you're trying to create conditions that are really favorable to the biology, to the soil life, right? To worms, fungi, bacteria. They don't want stuff that's like floating in the air and not in contact with the soil. So put the big stuff in contact with the soil really nicely, and then you're just working your way smaller from there, right? Slightly more fine material, just nestling it all in so it's nice and in contact with itself and in soil. It's all nice and going to be covered up with whether it's the leaves, the sticks, the smaller branches, or ideally the mulch that you've sent that through, right? So if you can do it in that way of like the most coarse material, working your way up to less coarse material, and capping that all with like a nice dense covering of wood chips or leaves or grass, just make really inviting conditions. Just keep that in your head. You're trying to create inviting soil conditions, or inviting conditions of the organic material to really invite the biology in. Once you do that, then you plant your small stuff. And so this is kind of where the dance of figuring out like, all right, you're mulching like that in your tree lines, but then in your alleys, you're doing really light mulch, right? Because you don't maybe want to have to be pushing heavy wood around small little vegetable seedlings. So I would be prioritizing, like when you're organizing the material, prioritizing the high value trees with the highest value material, right? The high, like the slow release fertilizer, the wood that's going to take the longest to break down. Prioritize maybe the grafted trees or the high value stuff. For the alley crops, like the vegetable beds, put a light covering there, not maybe heavy wood. They don't need that. They don't want that. So then once you've got things mulched, then you're just scraping the mulch aside, and then you're planting your little vegetables. All right, so you've got a nice like rough covering of, say, pea straw or grass. You come in, you push some to the side, and you plant your leafy little vegetables. So that's what I mean when I say plant bigs and then plant smalls. Scoop mulch, plant it, close it back up, done. Then you're also planting your seeds. That's the last stage. And so you've got your tree line, you've got your big stuff planted, you've got your banana corms, big stuff, banana corms. You've got things mulched. The heavy mulch, the nice high value mulch is around your trees or the tree lines. You've got little vegetable seedlings popping out where you've planted them. And then maybe in that tree line, you go and you plant all your little diverse mix of seeds that you've been collecting, because you've done the recommendation and you've gone and just collected a ton of little diverse assortment of seeds. So that's more or less the installation protocol. You're pruning and organizing the material around, prepping the soil, adding the inputs and shaping the beds, planting your big stuff, right? Corms, grafted trees, mulching from the most coarse to the least coarse, creating inviting conditions for the biology. Then you're planting your small stuff, scrape the mulch away, plant it, and seeds. All right, so that's the order of operations. And obviously this is, again, just high-level pattern stuff. You're going to refine this as you go. There's no one right way to do things. This is what works well for me. But even within this, there's so much nuance. We could spend all day walking through the details of this. And that's how you do it on site. You go through very nuanced, and each of these stages has like 4 different sub actions that you need to do. But at a pattern level, this is what it looks like, so you're not tripping over your feet doing the install. And hey, if you want direct access to myself and a global network of other professional food foresters, the fellowship is where the magic happens. We'd love to see you in there. All right, food forest management. This is the last module. We're going to look at strategy and techniques for managing your food forest or your agroforestry system. Now, keep in mind, management is 95% of the work. We've said this before. You've heard this plenty of times, but not just from myself. Management is everything, right? And management is where you become an agroforester. This is a fun little expression or an idea, but it's like Yoda in the food forest, right? You do or do not, there is no try. I think Yoda said that. I don't know. But I envision a little Yoda character deep in his ancient forest who's had eons and lifetimes of managing an agroforestry system. If you're managing an agroforestry system, you are an agroforester. Because that's where the practice of you actually doing it, you become that. It's not a practice. It's not a trying thing. If you are managing, you are doing agroforestry. You are becoming an agroforester. So you need to do with management. This is the most exciting part about it. Now, this also is where you can find success or failure with your agroforestry. Now, obviously, if you're planting trees, it's not a failure because you're planting trees. Fantastic. But because management is everything, you can have systems that are neglected and not managed, and they just become these almost like really sad places to see, right? They don't work. The aim of the system, which was to be productive, not happening. And so regardless of how good your design is, management will still determine your success, right? Even if you have a poorly designed or poorly planted system, good management will make it a good system. You can have a beautifully, on the opposite side of the scale, you can have a really beautifully, perfectly designed system, perfectly planted, but if it's not managed well, it's going to be a bad system. So management is more important than pretty much all the other things combined. Like as long as you're getting a good seed stock and getting a good diversity of seeds in the ground and you're managing it, you're doing great. You're doing so good. Management is also what is going to accelerate the development of your system. So this is just a very simple illustration to showcase this. But the difference between these two systems right here, what is it? The difference between these two systems is on the top here, each of these successional stages is going into senescence, is nosediving in growth. It's slowing things down before the next succession of species hits that growth curve, moves the system forward. Versus here, this would be more akin to a managed system where just before each of these species' life cycles begins to nosedive into its senescent stage, the disturbance happens, the growth pulse shoots it up, and it doesn't nosedive the system because the system is dragged down by whatever species like across the whole system is going into senescence. And so if you're avoiding that at each successional stage, you really do accelerate the growth of your system. So instead of taking, on its own, natural regeneration can take 40 years, right? Just allowing like an area to go undisturbed, it moves into its secondary succession of like scrubby, weedy trees. It can take 40 years for a native forest to kind of like emerge through that. With management, that can be accelerated to like less than 10 years. Species management is everything. Doing these regular interventions is what will accelerate your system forward, accelerate the succession with pruning. And it's a synchronized disturbance. This isn't going out every evening and pruning a little bit here and a little bit there. These are heavy synchronized disturbances, almost as if you're acting like a windstorm, or even more intense than a windstorm, acting like a hurricane, right? Imagine a hurricane comes through, the place is leveled, right? It feels just like tons of organic material on the ground. There's like so much more sunlight. It should look like chaos. It should look like a war zone. I've got a ton of, my own experience. There's some stuff I've shared on YouTube about going through that process. There's a great video over the span of a week going from a really overgrown system to an absolutely like demolished, heavily disturbed area. It's that synchronized disturbance that gets everything on the same page at the same time. In that span of the next 2 months, everything just rebounds so hard and fast in sync together. It's a system, right? Synchronized disturbance. Sounds like a band name. Be the windstorm. But really, that's what you should be thinking. That's what you should be like mentally envisioning as you go in. Like you're trying to be really destructive here in a controlled way, right? The difference between you and a windstorm is a windstorm just breaks branches and leaves, bad pruning, right? Like you're leaving nice cuts exactly where the tree is kind of like asking to be pruned, right? Now what you're doing is you're going from that overgrown, full state as it starts to nosedive, and you're taking it right back. You're doing that big disturbance, a ton of organic material on the ground. It feels naked, it feels open. That's perfect because that's going to lead to a growth pulse. Now, how and when are you doing that? You're emphasizing your crops, right? If you're growing a certain kind of crop that needs to flower at X time, you're probably going to want to be doing a heavy prune right before then. Because in most cases, a lot of our productive fruit tree species are dependent in some way on that degree of sunlight. Sunlight, airflow, temperature. All these things are like, they all are wrapped together, right? And so whether it's like low strata species, especially berries, guavas, coffee, etc., or even like, a lot of the more classic fruit trees, apples, pears, plums, peaches, nectarines. These are species that are really going to benefit by doing that like pre-flush of flowers prune, like a heavy prune. And so part of it is just like learning your crop, understanding what species are that you're trying to, what your target crops are, what their seasonal cycles are, and how do you prune to accommodate for that. The other big pattern for pruning in sync is just at the start of your growing season. And so this takes us back to our different climate types, right? If you're in the tropics, you kind of have like a lot more opportunity for heavy pruning because things grow so much faster. The growing season is just a different world in the tropics than compared to the Mediterranean. Or maybe you have fewer opportunities for those really heavy prunes, right? And so maybe it's somewhere in between with a temperate or a subtropical. Maybe you can only get away with like one really heavy prune per year, and then it's like progressively lighter prunes. That's part of your own research. You're learning that you have to do. You're creating a laboratory, right? Your food forest, your agroforestry system, you should be acting as if it's your laboratory. You're doing research, you're learning, you're observing, you're growing. Part of that is I can't give you the answers. I can give the answer, like the answer in the example for my site in the subtropics, where at the start of the growing season, I have like the biggest, heaviest prune, and then throughout the season, the pruning interventions get smaller and smaller, and then frost happens. That's a pretty big reset intervention, and then we start over. I do a really heavy prune at the start and then progressively less. I can speak to that because that's my own experience. You have to do the research for your site. You have to gather that evidence. Other people, probably here in the fellowship and the pioneers, everybody's got slightly different contexts and climates to be playing with and making those observations about. But that's something that you're paying attention to when you're timing your pruning, your disturbances, your crop emphasis, and the start of the growing season. And basically, the last thing is you're allowing for a full recovery. You don't want a plant community or your system to be like mid-recovery, not quite there yet, and then you come for another really heavy prune. You want to give it that chance to rebound. What I mean by that is you want to be able to pull the same amount of organic material as you took off originally. Actually, you'd probably rather have like more organic material. So it's recovered at least that same amount as what you pulled off during the last intervention, and probably put on even more since then. That's how you kind of know it's gotten at least a full recovery. And then again, you'll notice once that growth curve starts to hit and it's slowing down, you're paying attention, right? And to a degree, you're allowing senescence to a degree, right? So for me, frost is an important thing that I'm trying to prevent. I'm trying to protect young frost-sensitive seedlings in the middle of winter. And so what I do is I allow a certain degree of senescence from certain trees. I allow them to get overgrown. I allow them to go into senescence because the function that they're playing in terms of the frost protection is more valuable than me keeping senescence away, but also opening the system up, especially the high value young species in the understory, exposing them to really hard frosts. So there's always a kind of a push and a pull between different dynamics. And again, that's the work. That's the work that you have to figure out for your site and your context. That's the work. Now, what happens if you don't prune? Group senescence. This is I'm gonna make an old person home and name it group senescence. It's gonna be the name on the front of the building. Group senescence. That's what happens when you don't prune. The whole system starts to collectively go into that slowing down and reproduction stage. We spoke on this earlier. Your photosynthesis is reducing the ratio of like mass to photosynthesis, right? We've all seen those like really old stagnant trees, right? Where they kind of like look just like stretched thin, where like there's a ton of wood, but you can kind of tell they haven't been pruned in a long time and they're kind of like sickly. And the only living leaves are kind of just like way out here on the ends. That's a tree that's got a really low photosynthesis to mass ratio, right? You can see all the mass, all the physical mass in the tree, all the branches and the wood for how much photosynthesis it's doing just on the outside edges, versus a young tree that's like constantly kind of like kept in this growth mode where it's growing and it's pruned, it's growing and it's pruned. A lot more photosynthesis to mass, right? So you're keeping it from going down that senescence slide. You're keeping it in that like high photosynthesis production rate. Where you're also, when you're not pruning, you're increasing pest and disease pressure or availability of pest and disease pressure, right? Because they're just doing their job. It's not like they're a terrible thing. They're just doing their work ecologically. Tree is going into senescence. It needs to be reset or pruned, cycled back in. Pests and disease are a great way of doing that. So are vines. So they're just doing their function. And that's part of the agroforestry mentality shift, is that you're looking at things from a system point of view now. You're not looking at the individual tree and saying, how do I keep this one tree alive? Is what's the feedback that I'm getting here? Why is there pest and disease pressure? Oh, because the ecosystem, something is out of balance, right? That's filling a function. That's fulfilling an ecological function that I need to learn and address. You should almost be thanking the insect and the disease pressure. Thank them because they're giving you an opportunity to see how you need to change your management, how you need to change the system, right? They're just doing their job. But that's what happens. When you don't prune, go into group senescence, pest and disease pressure skyrockets. And ultimately what you end up with is, you leave systems for long enough, you end up with an emergent dominated ecology where there's just a bunch of emergent species, right? Top canopy layer, full sun, and very little canopy diversity, right? We see a lot of this in natural ecosystems, whether it's a secondary succession, you see just a bunch of early pioneer species. It's a simplified ecology. So that's what you're working to avoid, right? Like, for example, my system at home, if I just walked away and didn't prune anything for 10 years, at the moment, it looks like this. I'll draw a little. At the moment, there's all these different layers underneath the emergence, all these different strata, right? Medium, low, high, emergent. But if I didn't prune for 10 years, these emergents would begin to dominate. No resets would happen, except for the windstorms that naturally occurred. But because the emergents begin to dominate, what's going to happen is the things underneath are going to be starved of sunlight that they need. That's part of the dynamic when you're pruning. Then it becomes an emergent dominated ecology, more simple, less resilient, less productive. So those are the consequences of not pruning your system. So you need to prune your system to avoid senescence, all this pest and disease, reduce photosynthesis, and just an overall simplified ecology. Keep on top of management. Pruning styles, pruning strategies and techniques. Number one, apical pruning. Apical as in like apex, right, of a roller coaster or whatever, right? The top. When you're doing apical pruning, you're pruning like the main leading growing point of the tree, right? Typically, you're doing apical pruning on your emergent trees, right? Typically, some kind of fast-growing, straight upright tree, like a eucalyptus or a poplar or a willow, acacia, right? Apical pruning can be done in a few different ways. You can do this with some kind of pole saw, which depending on your scale and your equipment might be the way. Or you can do this with a ladder. Either way, you're getting up and pruning the top of the tree. We'll dive into more details, but that's, in a nutshell, apical pruning is that. You're setting the height of your whole system. Because if you think about it, you're doing your apical pruning on your emergent trees, right? On your highest layer. the height of your highest layer will determine and dictate how tall everything else in your system can be. Right? Like if you're gonna keep your system capped at 5 meters, that's how much space you have to play with underneath there. If you're risky and if you're willing to prune things at 7 meters, which doesn't sound like a lot, but it's a big difference, you have a whole 2 more meters to play with, to grow more underneath. If you're trying to keep a dwarf system, have even less. So the apical pruning is actually quite an important part of maintaining an agroforestry system. It's setting the height and the allowances for what you're growing within your system. Stratification pruning. So this is kind of the example that we've been talking about this whole time. We've got our low strata, we've got our medium strata, high, and emergent. All right. Your stratification pruning is essentially teasing apart the layers. T-A. You're teasing apart the layers, right? They grow together and you tease them apart. They grow together, you tease them apart. That's what's happening with your stratification pruning, is you're optimizing and allowing for more sunlight and airflow between the two layers. And so after we prune, we've allowed and created for more space between each layer. And here's the key thing. You want at least 1 meter between the bottom and the top of the neighboring canopies. 1 to 1.5. And so what that does, it pretty quickly starts to demonstrate, all right, well, the top of your system really is dominated and dictated by where you're doing that apical pruning cut. All right, if you're doing your apical pruning cut at 5 meters, and you need 1 meter of space between the bottom of that and the top of the next layer, the top of your next layer is at 4 meters, which maybe that's your high canopy tree, let's say your avocado, that's going to want to occupy at least, like probably at least 1.5 meters, 2 meters. And so then the bottom of your avocado is at 2 meters. Do you have space to squeeze a medium and a low in there? I don't know. But what you're doing is essentially you're organizing your system in a way that for that area anyways, between 2 and 4 meters is where your high canopy avocado lives. So when you're doing your service pruning, which we'll get to shortly, you just keep resetting your avocado to those bounds, 2 meters to 4 meters. That's where the avocado lives. 5 meters and up is where the eucalyptus lives. I keep pruning it back to 5 and it keeps resetting to there. And then maybe your medium strata is at, say, 1.5 to 0.5. All right. However you want to organize it, whatever species that is. Maybe it's cacao or some kind of citrus. All right. But the example is you're organizing this. And again, don't feel overwhelmed by this because you're going to get to these levels of detail when you're first starting out. Just like put all the seeds because you're not going to know. To give yourself options. That's why the importance of like just giving yourself the options is really key, so that you can learn, select, see what each species needs, and then give yourself the opportunity. So that's stratification pruning, is your TA. You're teasing apart these different layers because that's what they're going to do. They're going to grow together. They're going to blend, and you're going to tease them apart and put them back in their medium, high, emergent, and low strata. That's the maintenance. That's the work. Another strategy for pruning, specifically as it relates to support trees, is coppicing and pollarding. There's also staghorning, which I'll cover just briefly. So a coppice is basically cutting a tree down at ankle height. What it'll do is it'll regrow with a bunch of shoots over the next season or two. You're identifying the ones that are the strongest, maybe 1, 2, or 3, and you're allowing that to turn back into a tree. You do another coppice cycle, you bring it back to here, you harvest either the wood for organic material, the timber. If you're doing it on like a 1 year interval, maybe that's more like a basket weaving willow. If you're doing it on like a 3 or a 5 or a 10-year interval, you could be harvesting wood for other reasons, but that's what a coppice cut is. Right? You can also coppice support species like Mexican sunflower. Basically, anytime you're cutting something at ground level and it resprouts, that's called coppicing. A pollard is similar, but it's just at or above shoulder height. So you'll see similar things. You cut, it resprouts. Over the coming season or few, you identify which ones are like the main strongest leaders. You keep those. And again, depending on the pruning cycle, you leave it for 1, 2, 5, however many years, depending on what your goals of the system are. And then you keep resetting it to the same point, at or above shoulder height. Now, I keep saying at or above is because you can do a high pollard, which is basically how we're treating our emergent species like the eucalyptus, our emergent support species, because, well, we need to be allowing space beneath them. And so basically same deal here, except instead of at shoulder height, it's up at 5 meters, which again, easy to say, much harder to actually do. So like, you got to go do this stuff. You got to learn, figure out what are the techniques? How do I actually want to do this? But that's the idea, is there's a few different strategies for managing biomass species. The staghorning is similar. If we just draw a little tree here, it's basically just like, imagine a less severe, you're kind of like, imagine antlers, right? You're pruning it back quite heavily, but maybe just not like a full reset. Like you're leaving some of the detail of the branches, if that makes sense. There's videos, we'll cover it. But those are some of the easy way of like organizing pruning strategies for biomass trees: coppicing, pollarding, and staghorning. There you go. Now we get into the fruit and service pruning. The pruning of fruit trees specifically in agroforestry systems. There's kind of a sequential step-by-step nature to it, right? Step 1 is you're pruning the crown, right? The main center at the top middle. What that's doing is that's opening opportunity for sunlight to get into the rest of the tree. So you're climbing up and you're pruning the main canopy out. And that's quite easy once you've determined what height you need to be keeping that tree at within the agroforestry system. Because then you can keep going back to the same place and you've already established that kind of formative pruning, that foundation. The second thing you're doing is you're pruning any crossing or rubbing branches that are like rubbing against each other. Invitation for disease. You don't want it. No good. You're also pruning any branches that are shooting directly up or down. So any branches that are pointing straight down or straight up, in general, you're pruning those out, right? Because if it's pointing straight up, it's typically a water sucker. It's like a very, very vegetative growth. Not going to be super productive unless you're like doing a full reset and like getting a new foundation for the tree. And if it's pointing straight down, that's not the kind of growth habit you're interested in either. So straight up or down, they go. You're also pruning branches that are pointing inwards. So pointing, like growing into the center of the tree is not what you want. And the last one, number 5. What was number 5? What was number 5? I have it here. Terminal pruning. You're taking the branches that are going outwards and you're pruning the ends. So instead of just like letting the branches that are kind of going the right direction, instead of just like letting them nosedive and continue going down, you're just terminal pruning, cutting the ends, consolidating, and giving them new opportunities for growth to shoot up. instead of just, because if you prune the whole tree, but you don't do the lateral or the terminal pruning at the ends of the branches, they'll just keep growing downwards because you haven't given them that prune, that stimulus to shoot at the dormant nodes, because every branch has dormant nodes just waiting for a prune. So you want to activate that as you're doing this whole service prune, whole system reset. Now, this is a pattern level, right? Pattern level, crown, rubbing branches, straight up and down, inwards, and terminal. Obviously, there's details like that relate to specific fruit trees, time of year, etc. That makes sense. But at a pattern level, these are kind of like the 5 types and stages of pruning to do for your fruit trees, service pruning in your agroforestry system. Hopefully that's helpful. Are there any questions about that from anyone who's here live with us before we move on to the final, what I believe is the final module?
Yes. So I just did a prune of an old apple tree, and with apples, you want to guide the branches down because that's how, or not right down, but you want to guide them down to the ground so that they start fruiting. Otherwise, if they start going upward, they don't fruit as well. Is that correct?
Yep, absolutely.
So and that's specific. Yeah.
Well, that's a key thing there is like straight down is the difference. Like branches that are pointing straight down, no, that's not what you want. But the apple thing, yeah, like same with plums and a lot of these temperate trees. Like if you can train them and bend them a little bit down on an angle, you see orchardists do this all the time. It increases fruit production. But when you start going like straight down, then it's a different story.
So just on that, with your terminal pruning, you do want to encourage the branch to keep going down, but not too horizontally down. Is that correct?
On the
or
terminal
have I misunderstood that? Yeah. So the last step that you talked about. So if you take that the end off, you want to keep encouraging it to grow at like a 45-degree down to keep that fruiting nature rather than getting that upward growth.
Yeah. Yeah, like you wouldn't be maybe pruning it like so close. Like if this is the center of the tree, you'd still be allowing it to like have that, especially for things like apples and, you know, where you know it increases fruit production on those branches. Like you're not pruning it here, so it shoots up straight, but just some kind of terminal pruning on the very end.
Yeah, cool.
But again, this is all pattern level stuff. So maybe, you know, no doubt there's going to be like gray areas and details that this doesn't cover. It's like, you know, you can't really put it together like an exact guide for like all fruit trees need to be like, you know, doesn't exist. There's too much diversity.
Exactly. You can prune it 1,000 ways.
Yeah. Cool. It's getting really dark here and this light is changing drastically. So I'm going to try and adjust. Other questions about fruit tree pruning or pruning in general?
I've got another question as well. So you talked about how with your seasonal pruning, you do a big intervention at the start of the season. So for like a temperate system, you've got all your flowering that happens with low your fruit trees. And you've got everything pretty much waking up. You'll have your emergent species or your pioneer species that will be your evergreens, but most of them will be dormant species. So are you hindering growth if you're getting all this like coming out of winter dormancy and you're chopping that down and then it suddenly goes, oh, what's just happened? I'm trying to grow and it's cut me back.
Yeah, that's part of the beauty of having like a lot of support trees, because you can do a really heavy prune on your support trees. Like your fruit trees are going to feel that growth pulse. They're going to feel that effect. But also not being afraid to like, you know, prune the fruiting trees, because you're going to have to thin fruit anyways. Like if you're talking about mature systems where you're needing to thin fruit, like part of that's going to be accomplished by doing a prune on those trees early spring when they're flowering. So I'm not afraid to prune things, temperate species in those systems as they're flowering, because I know that ultimately it's going to be of service to the system and the tree.
Yeah, to prune then rather than when there's too much fruit on the branches.
Exactly. And then you have airflow problems because you didn't want to prune them, and you know, all these roll-on effects. Fantastic. Cool. I think this is, yeah, we're almost there. Cool. I'm gonna not even bother shifting the recording. We're just going to dive right into it. So biomass placement. So this is such a key part, especially in early systems, right? While your systems are still young and like developing, especially the metabolism of your soil biology, the ability for it to like consume organic material, the amount of organic material that you have in the early stages of your system, it takes more attention to detail. It takes a little bit more like finesse and being deliberate. So placement of the organic material, especially in the early days, really important. Here's how it looks. If this is your tree line, TL, where you have all your trees and your seeds growing and germinating, right there, you've left a gap so there's not mulch covering it, right? There's not a huge amount of like pile of wood chips blocking up airflow and keeping seeds from germinating. And maybe that gap is only 5 centimeters. Maybe it's just that. But it's not covered up in mulch. The mulch is happening on the outsides. That's keeping a lot of moisture in, building a lot of microbiological activity, right? And that's where you're going to keep depositing prunings and mulch. You don't need to be trying to like weave it in between the tree line and all your seeds germinating. You just put it in your lines alongside the tree lines. Perfect. And this is where you're generating some of that herbaceous biomass, right? Whether it's grasses, Mexican sunflower, maybe it's some kind of crop and it's just part of your alley crop system. But in terms of biomass placement, that's where that's happening. And if we look at that pattern that we were talking about earlier of like most coarse to least coarse, the same thing applies. If you're starting out with an amount of organic material, you're just layering it so it's nice and in touch with the soil, and then covered up in whatever like fine or wood chips, just to keep it nice and contained. But that's where it goes. Your 2 mounds on either side of your tree line, thick amounts of organic material, and then just a little gap on your tree line for things to easily germinate. And just to reiterate, when you're adding new plants is when you're doing those heavy disturbances and you're continuously seeding your forest. You're continuously acting like the birds and the other animals that move through and they poop seeds out. Keep planting seeds in your system. So even if you've got a system right now that you haven't planted some seeds into recently, go do that. Go plant some seeds. And there we go. That's been almost 4.5 hours of Syntropic food forest education. It's dark here. I look like Avatar with the blue light. Hopefully you've got some good value out of this. It's been just an absolute blast over the last 5 years to like go from not knowing any of this to uncovering this whole world of information through my own lived practical experience, but also spending time with other practitioners and experts. It's been an absolute pleasure to then have the opportunity to collaborate with other members in the food forest pioneers and the fellowship to consolidate these ideas. That's how this has been made possible. So thank you guys who are in the pioneers, the fellowship members who have supported this, have contributed to this growing body of knowledge. No doubt there's a ton of stuff that I left out that I just did not have time for. It's been 4.5 hours. That's about my capacity for sitting in one place at a time. But hopefully I've done my best and done an effective job at communicating in such a concise way to you everything that we have to offer and to explore. Hopefully now you go do something. That's my main thing. If anything, I want you to actually go implement something that you learned here on your landscape. That's where the learning happens. So hopefully you got some value out of this. If you have, share it with somebody who you share land management with so they can learn alongside you. Share it with somebody else who might find this valuable. And if you really enjoy the direct access, if you want to be able to ask questions, if you want to go deeper into each of these topics, be part of the conversations with guest experts, see a ton of like exclusive behind the scenes stuff. All of that's happening in the Food Forest Fellowship. Otherwise, thank you so much for your time and attention. Hopefully this has been valuable. Maybe there's other questions from anybody who's in the live stream. We'll take a moment for that, but thank you very much for being here. It's been a pleasure.